taking more depth of this during the peering workshop that will be taking place Wednesday and Thursday. So if we say we want Okay, I think it's better now. So our world today is actually a connected world. And when we say connected world, we mean the world where everything is actually connected. We hear these days where people talk about Internet of Things, and an organization actually said it's actually Internet of Everything. But whichever way you look at it, is our world today is connected, that almost everything has its presence on the Internet. The Internet yet. And that's one of the things that will be the main reason that what we will be driving through the course of this event. So, okay, I think I'll move on without the slides. Sorry, please be patient to resolve the technical problem. Okay, so I think we are good now. So I'll be in topic. Why is it necessary for us to pair, and also some options when it comes to pairing and the actual role that an IXP plays. So a bit of terms that is IAP, Internet Access Provider. Most times, the people we call Internet Service Providers are actually Internet Access Providers. So, healthcare, higher stream internet service provider through which they now give access to the end users that also use the service. So, to get access to the internet, wherever you are in the world, one major critical thing that you need an internet service provider. So how does the internet service provider do that? What they do is, the internet service provider get access to internet, usually higher bandwidth, and then it sells down. It sells to other enterprise organizations, it sells to home users, it sells to institution and all others to be able to have access to internet. But so what exactly does the internet service provider do, although there are so many in making this work for the internet service provider, for you to get internet access? They do many things, but primarily what an internet service provider do is they buy and they sell bandwidth. And by saying internet service provider here, I'm actually referring to giving access to internet. Taking it down, this service is actually being offered by the acronym that I said I'm not so good with pronouncing. That is the IAB, Internet Access. Service provider to be usually you need to have a means of connecting to the upstream providers. In the early days, even in Nigeria, then when you have internet service providers springing up, so the early day service provider in our hand there, what they do is they get what is called default route. They don't handle the complexity of handling the details of each network and how it runs. So they have a direct connection that goes to their upstream provider, and they just tell the upstream provider that, okay, whatever I sent to you that I don't know how to get there, you just find the way of getting to wherever it needs to get to. And then anything, any traffic that is coming to my hand, because they advertise their own network, it comes back to them. But as the ecosystem grows and the service providers themselves grows, this system becomes less scalable for them. They have to move up into using the main protocol that runs on the internet, that is BGP. So, and as they do that, they will need to be exchanging what is called prefixes back and forth. So in order for the service provider you have, let's say, an ISP that has network with the identity 10. Let's say that's the IP network that he has. He advertises to his upstream provider in order to be able to get access to other networks that the upstream provider knows. Then he receives prefixes that belongs to those other networks from his upstream provider. How the upstream provider gets that, he doesn't really do much about it. So that's primarily what an ISP will do, a bit technical, in order for him to get internet access. Upstream provider too have another service provider that he also connects to that gives him access. So I'm actually leaving out, there are other parts to this in the sense that, you know, the service provider needs to put in place infrastructure, set up links, set up all that. But I'm focusing today on this aspect of prefix exchange the peering and the activities that happen with the routing protocol that is being used, which is BGP, over the internet. So there are two ways that an internet service provider would get access. Is either they have the option of doing what is called a transit or through peering. Those are the means through which the service provider can get access to prefixes or learn about different networks from different parts of the world. What's the major difference between these two? There are a lot of talk about what each one is and all that, but the major difference between them is that when you get transit, you get access to networks, but it's a business arrangement where you have to pay to your upstream provider to render that to you as a service. Whereas in the other case of a peering, when you are peering, it's more like a mutual arrangement between you, it's also business though, between you, your own network, and the other network where you exchange traffic together. So in the case of the major difference is the fact that somebody is paying. If the ISP is getting a transit from an upstream, you are paying the upstream. But if it's a peering relationship peering arrangement that you have with the upstream, it's something that both of you will actually exchange traffic together and you have mutual benefits. So why do we pair? Because when you have access to internet already, so why do you want to go into internet pairing? And let me make it clear, even in the case where you get internet transits too, you still need configuration that you still do peering. For peering in this context, we are actually using it to distinguish between transits as in terms of the arrangements that you actually make, where one is a kind of contract arrangement that you are paying someone, and the other one is like a mutual agreement that you with the other service provider that you pair together and you exchange traffic together. So the benefits that you can get are why you would want to pair. One of them is savings. Because when you get a transit provider and you have to pay the service provider, the transit provider, and the cost is high. In the case of peering, what you are doing, you are also getting access to internet networks, some of which will even, most of them you will also get it through your transit provider, but this time, through this arrangement where you don't have to pay that much. Although some cost still comes in terms of how you execute and all that, but it saves you cost. It saves you cost in terms of because the cost is cheaper. It saves you costs in terms of equipment because you have to pair with so many networks. It saves latency. When you pair with a network, it's like you get a kind of arrangement rather than going through your upstream provider. The network that you want to, you have access to that network directly. So there are two options for doing the peering. Let's say we understand peering, we get the benefits that comes along with it. Okay, so we are ready to pair. So how do we go about it? There are two options when you want to pair. You can either do a direct circuit peering, or the second option is you pair through an internet exchange point. The first option, that is direct peering, what it means is direct in the sense that you have to create a direct, or you have to have a direct circuit that connects to the other network that you are pairing with. Expanding on the previous case where the ISP that has network 10 actually pair with the transit provider, but this time is now looking at other network. Maybe they've done some analysis and realized that they are exchanging a whole lot of traffic with network 3, 4, and 8. 3 and 8 is within the same locality, while 3 and 4 is the same locality, while 8 is somewhere far away. And then because they now say, okay, let's pair. And then they start this, which means you have to set up a circuit that pairs with each and every one of the service provider that you deem fit to pair with. This is good. At least it gets the job done based on what we've discussed. Depending on how you work out the commercial, it might be good in some cases, but there's need to strike a balance. If this is what one is running fully, there are some disadvantages to it. One of the disadvantages to this, it means that when you are paired, as you identify each network that have your potential pair, you have to pair with each of them individually. If you have 50 networks that you've identified, it means you are pairing directly with 50 networks. So let's say we have 2 service providers within the same country. They realize one another, they can pair with one another. If there are many too, they also have to pair with one another. If you have another network that you want to pair with that is outside your country, you create a circuit that goes down to that particular country and then you pair. So it's not so scalable. Another option is through an exchange point. An exchange point provides infrastructure where networks can exchange traffic together without having to go through an upstream provider. I'll explain a bit of that in the next slide. But what that means is you get an exchange point where the networks that you are interested in are already connected. And all you need to do is to have just one single connection to the exchange point. The exchange point, it means they reduce their cost of transit and their latency too will increase because it's now a direct connection, not going through multiple ops. So that's basically what an exchange point gives you. It gives you that central point of connectivity. You are connected directly to the upstream, to the networks that you know, be it content network or even eyeball networks. So an exchange point, like I said earlier, is that it provides that critical infrastructure where networks can connect to one another. It doesn't have to be an internet access provider or internet service provider alone that can connect to an exchange point. So you have telcos, you have the ISP, you have critical infrastructure service providers, you have content network like Google, Netflix, so connected to an exchange point. It means when you're accessing those networks, you are also having that fast access to them as well. So exchange point provide all that. You have cloud service provider. So all these people being a IP-centric service providers pay more, which results to even the end users paying more at the end of the day. And they won't be able to use much of the service because they might not even be able to afford the cost. So it helps to save cost. It helps to save cost, reduce latency, helps to save cost, both for the internet service provider as well as for the end users that are also paying for it. It enhances local connectivity and improve internet experience for end users because the experience will be better. It's reduced overall cost related to providing internet service. I said earlier that there's difference between, I'm using the term ISP to actually represent all that, to represent somebody that provides internet access, but an ISP is actually much more than that. An ISP is people that provide services that you use over the internet. So one of them is a high AP, someone that provides you internet access. There's a whole lot of services that are available on the internet that a service provider can offer. And you see a lot of our service providers too in Nigeria are doing so many other, they are rendering many other services like cloud services, streaming services and all that, besides giving internet access. So it helps to foster that kind of innovation to do multiple different kinds of businesses. It fosters innovation. It promotes and encourages creation of local content. It encourages people that are, maybe they develop applications, still around creating innovation. You develop application, you have this central point of connection where you know that all networks in the country actually have presence. It means that you have one point of reachability to all the networks. So it also attracts foreign investors. When people see that there's so much eyeball networks and there's so much traffic within your country, it encourages people to know that there's so much traffic within that country, and it encourages them to invest into the country, that the economy is doing well. So in Jacob, I work with Internet Exchange Points of Nigeria. Internet Exchange Points of Nigeria actually offers the service of an IXP in the country. At the moment, we have a 65 connected network. The traffic level is growing. Now we have 130 gigs of traffic being exchanged locally. We are a layer 2 IXP. We have POP spread around different parts of the country. Our objective is to have presence in all the regions of Nigeria. At the moment, we have presence in the north, we have in the east, and we have stronger presence in Lagos, where we have more networks. So POPs are in Abuja, Port Harcourt, Kano, and we have Lagos as well as ngNOG. We have access to some other services beyond just having direct access to eyeball networks that are available when you connect to the exchange points. We have Satrum 1 time server and quite a number of DNS, DNS servers that you can access when you connect to the exchange points. So we talked about the fact that we want to get internet access to be available to everyone. It will become available to everyone when the service itself is readily available, one, and when it is affordable. Many of us would want to actually get access to some services that you see that maybe when you travel abroad, you see people have access to. They watch videos, they access some services, but you just can't. You turn on your phone and then you are streaming, and before you know it, your data went down. And then you will be discouraged to even go the next time. So, but if the cost of your bandwidth is actually not something to worry about so much, that wouldn't have been a burden on you. You will have been able to enjoy the service the way any other person from any other part of the world will do. So what that means is if the cost of accessing internet drops, it means people in the village
Okay, thank you very much, Mr. Jacob. So we'll take a few questions if we'll have, or maybe we'll take the next presentation and then Jacob will come back if there's any question. I don't know if anyone has any question to ask. For those who are new to pairing or anything you want about pairing, I'm sure Jacob has tried his best to explain to us what's pairing about and how you can get one. Thank you very much. All right. Okay, so the next presentation will be from Edith Udeagu of NIRA. She will be telling us about NIRA and what the .ng brand is about. Please, a big round of applause for her.
Thank you. Association. We are the custodians. We have the infrastructure. We manage the infrastructure that deals with our online identity. We're just waiting for them to bring the clipper, but our responsibility is a delegated responsibility from the National Information Development Agency, NIDA. Actually managing a national resource, which is the resource that belongs to you and I, not just NERA, and it is our responsibility to promote the .ng, which is our online identity. I would speak a little bit of what a domain name is, what a TLD is, and what we consider when we are registering domain names, and why some of us need to be on .ng, the challenges that we face, and what we do to mitigate these challenges. Okay, so a domain name is your identity in cyberspace. This is the name that people type on the URL to locate you, your business, or your product. They can patronize you and make use of your services. And the domain names are usually, they represent a string of IP, some numbers. We can't remember these numbers. We are now advised to use the domain names which represent who we are and what we are. So for every item, Jacob mentioned it earlier on, IoT, every item now basically is on the internet. Your car, your phone, your fridge, your TV, everything that we all own now are recognized on the internet because of the IP address. So what is a top-level domain? It is the domain at the highest level of the DNS. And usually for the top level, there is always a suffix that represents that top level. There are three types. You either have the country code top level domain, which is the CCTLD, country code, CCTLD. Then you have the generic top level domain. Okay, I should give you an example of a CCTLD. For Nigeria is .ng, South Africa .za, US.us, Ghana GH, UK.uk. Okay, so for the generic domain, top level domains, you have the .com, the .org, the .net, and all, even .loto, so many other things in the world have become top generic domain names. Then we have the internationalized domain names, which represent the language of a particular country. Like for the Arabs, they have their own. You can see how it looks like, the Chinese, the Russians. In Nigeria, we have like 250 plus dialects. We have not reached the stage where we'll be talking about internationalized domain names in Nigeria. We haven't even got the numbers with the one we're using for the .ng, the country code. So we're not going to delve into the international domain names yet. Okay, so what do we consider when we are going to register a domain name? What am I marketing? What am I producing? Who is buying it? Where is the person who is going to buy this product located? So these are some of the things you need to consider when you are registering a domain name. Is the name I'm choosing easily memorizable? Is it something that is catchy? Is it something that people will be so eager? Let me go to that website and see what is on the offer. These are part of the things that you need to consider when choosing a domain name. How short is the name? You can't have too long names that people can't remember those names. And you need to avoid having hyphens, because sometimes when you want to type a hyphen, you end up typing an underscore. So you need to be careful. And then sometimes people register their domain names because they want to avoid other people registering it. You have a thriving business and somebody says, wow, it would be nice to use that name. And they put your name and they register it. So you need to register that name ahead of them. Okay, for us in Nigeria, where we want to boost our local content, we want to sell everything Nigerian on the internet, it is best that we use a .ng, which represents us, which is our online identity. And by the time you register the domain names, you are encouraging the resellers, you're encouraging the registrars, the NIRA accredited registrars. You are growing our economy. Now, in NIRA, for you to register a domain name, there are criteria. There are like 10, I think 11 second-level domain names. You want to register a school, a primary school, secondary school, you use the .sch. You're a government establishment, local government, state government, federal level, you have to use the .gov.ng. You're a tertiary institution, you use the .edu. You are an NGO, you use .org.ng. You are a military organization, you use .mil. So there are rules governing how you register these names, and you need to abide by the rules, okay? That is why we have those things we call the apple, the colorful things in the middle. They determine which SL, the second level you should use when you're registering your domain name. Okay, so for an overview of the .ng. .ng is the country code for Nigeria. It is our own identity. And NIRA, the association that is managing the infrastructure, is doing so on behalf of all of us, the federal government. It is a delegated responsibility. We have an MOU with NIDA, which permits us to do this work. And NIRA was set up with a stakeholder-led organization way back in 2005. Okay, and NIRA operates the 3R models. What we call the 3R model is you have the registry, which is NIRA, you have the NIRA accredited registrars, and then the registrant. The registrants are you and I who want to register a domain name. And then we go to these registrars, use their platform, and register the domain name. And they connect their own infrastructure to the NIRA infrastructure to enable them help you register the domain name. As of September 2019, plus all our over 200 million people in Nigeria, we, not NIRA, we have only registered less than 150,000 names on the .ng platform. This is not good enough. It simply means that we are not patronizing our own. .ng belongs to all of us, not just NIRA, not the accredited registrars, not me standing on this platform. It belongs to each and every one of us, and we have the responsibility to promote it. Okay? So, we have 67 registrars who are available to help in the domain name. Hello? We have them all over the world, NIRA accredited registrars. We have some from Senegal, we have Germany, we have Russia, no, we don't have a Russian. We have Americans, we have UK, and we have loads of Nigerians. You just go to their platform. Go to NIRA website, look for NIRA accredited registrars, select any one of them, and use their platform and register your domain name. Please, we always advise, shop around. Talk to at least 3 of them. See what they have to offer. See the extra services they can offer you, and then you choose the best that can serve your need. Okay? So, see the what I was talking about earlier. At the corner there, 149,508 .ng domain names. Not good enough. But we have noticed that there is gradual increase month on month. If you look at your right-hand side, September of 2017 was less than September of 2018 and less than September of 2019. It simply means the awareness creation is paying off, but it's very slow. So we all need to ginger up and do more and forget all those .coms and go to the .ng platform, okay? Okay, so why do we need to promote .ng? It's Tiwa Tiwa. I'm not Yoruba, but I know what Tiwa Tiwa means. Tiwa Tiwa means it is our own. We need to own it. We need to possess it. We need to promote it. We need to project Nigeria on the internet space. We need to promote our local content. When somebody out there is looking for a Nigerian business, they will, for me, each time I'm out and I'm Googling for something, I'll look so in Nigeria. So all those .ngs will pop up. So your business will be the first to pop up before all those .coms. Google is on google.com.ng. There's a reason why they're on .ng. It is partially to promote us and to give you a better search engine where you will spend less rather than going to look for google.com. You see google.com.ng pop out in front of you. It helps promote your business. It helps bring your business closer to those who have need of your business. So the online business is a very, very massive space. And the best thing you can do is for you to be online on .ng. Not on the GTLDs, but on .ng, the country code. Remember, when an outsider, and I'm telling you from experience, an outsider is looking for something in Nigeria, they rather deal with those who are on the .ngccTLD, not on the GTLD. GTLD, generic country code. For your name to be on the country code, it means that there have been checks and balances concerning the registrar's platform, did that registration, and then concerning you. Do some KYC. No. Our facilities are top-notch. We're using one of the best registry soft solutions in this world, not just in the country. We have services, internet connection from the best ones you can have in this country. So we use the best systems. We have sustainable facilities to provide. These are part of the reasons why you need to be on .ng. And it is secured. And we have redundancy all over the world. So when you're talking about the benefits of .ng, you're talking about the benefits to the registrant, the registrar, and to Nigeria as a community as well. So to the registrar who wants to register, there are vast, large names that are available there. It is unexhaustible. You can even type some of our local languages and attach .ng. For example, Nike.ng. Sure, Nike is N-I-K-E, but it is a Nigerian name. Emeka.ng. Not to talk about all the other English words that you have access to. So by the time you're a .ng or the NIRA accredited registrar, you have access to so many things from NIRA. Well, like now we're having this exhibition here. Our NIRA accredited registrars have been invited to be part of our booths because they are the ones who do the registration, not us. We just present the solution to you, but there is on their platform that you do the registration. So they have access to whatever NIRA has access to worldwide. It's a long-term investment for them, you know, opportunities, and they can get to compete with all the other global registrars. And of course, it will help their international presence or global presence. By the time they say, I'm a NIRA accredited registrar, you've done very well because people know you went through a rigorous exercise before you became accredited. Okay, for the registrants, you have, at the same time, you have access to all the support you need in this world because we are here local, just a phone call away, and we can always come to you to help you if you have challenges. Besides, .ng is your own national identity. You have every reason to patronize it. You need to be known as a Nigerian. Okay, so to the country, what does it do for us? Increases our income revenue generation. We have foreign registrars, we have local registrars, they are registering. Okay, 5 minutes, all right. So it helps us, instead of registering all those generic names that take our money out of the country, we are business and we are projecting our own local content online. And of course, it gives us access to educate our people. Like NERA now, we have the NERA Academy where we conduct trainings, free trainings for anybody who is a NERA member or anybody member of the public who wants to be part of the training. Okay, so how do we do the promotion? We have promos, we have complimentary offerings. You register a domain name, you get some aspects of your price for hosting reduced. And for all our registrars, they do a lot of marketing, road shows, social media adverts. We're having a .ng blogger session in Umuahia next month. So these are part of the things that are done, and the registrars are invited. What are the challenges we are facing? People say .ng is expensive. But let me ask you, what does it cost you to register a .com? You're promoting someone else's business. You're not promoting your own. And remember the continuous foreign exchange you ship out of the country every time you register a .com or any of those generic domain names. Please let us promote our own. And then people say, oh, it is Nigerian, it's going to fail. No way. We run top standard solutions and we have top standard infrastructure, and there's redundancy at our co-location centers. We are at the best co-location centers in the world. I cannot promote them, but if you go to us one-on-one, we would do that. Okay, so how do we mitigate these challenges? We need to get people more informed. We need to train our personnel. We need to organize more symposiums, and we need to be patriotic, please. You and I, we need to embrace the .ng. It is very important, okay? And we need to collaborate more amongst ourselves. So in conclusion, the more companies that promote .ng, the more we're promoting our online identity. It's so gladdening when you're seeing a cab on the road or a bus and you see so.ng, or you see some adverts on TV, so.ng. They are promoting us and we're happy and we're thankful to them. So please, all of us need to increase our usage of .ng so that we can promote .ng more. Besides, .ng is the future, so you need to get yours and you need to preach it. Don't just register it and pack it. You need to make use of it. And if some of the big names like google.com.ng is using it, some of the SMEs that are coming up are on .ng. What stops you from being on .ng? Nothing, absolutely nothing. You can be sure that .ng is secure. You can be sure that you have the support should you have a problem. You can be sure it is ours. Nobody can ever take it away from us. Thank you very much. You're welcome.
You know what NERA stand is? I'm sure now you're better informed about what NERA is.
There's somebody there with a hand raised.
My name is Nuruddin Ibrahim Suleiman, Sahel Telecoms from the northern part of the country. My question regarding .ng, what's the policy of NERA regarding .gov registration? .gov,
Okay.
anything that has to do with government. Is there, because sometimes you have this conflict between NIDA and there are issues when you want to register. They said you have to go through NIDA and so on and so forth. That's number one. Number two, what kind of protection does NIRA give to where there's a conflict between the owner of a domain and the registrar or a contractor that happens to register a domain for, say, a government organization or a company, and there's a dispute, and you can't keep the person from using his domain for a while, but if he's owing you money, what is the role of NIRA in this regard, specifically government? Because you have CDN telling you to register a domain for them. Probably there's a job you did for them, there's a solution you provide for them, and you did this registration. Unfortunately, some years down the line, they are owing you money after you have probably used your money to renew the domain again and again and again and again. Then they now use their federal might and say, sorry, we're taking back the domain and there's nothing you can do about it. That's why they're owing you. Now, how does NIRA come into this kind of situation to try to resolve it? Because my belief is that if you have spent money for an organization, irrespective of whether it's federal government or no matter how big it is, NIRA should be able to protect either the registrant, or whoever is involved in this. Thank you.
Okay, Mr. Ibrahim, right?
Nuruddin, yes.
Mr. Nuruddin, all right, okay. Any question I don't answer very well, we have the NIRA president here, and he will chip in and answer. Mr. Rudman, he's here. Okay, all right. With respect to .gov.ng domain names, there are actually policies governing how you register .gov.ng domain names. They belong to either local government, state governments, or federal government level. Now, we always have, if you go to NIDA website, there's a guideline there, which equally points down lawyer as well, and then we have an agreement with one of the top-notch lawyers in this country, so that if there are disputes that we cannot handle internally, we invite them to come. But we do mediation before we now think about going to court. Going to court is the last resort, but there are policies, rules are registered, and I am sorry, what our rule now says that if somebody has, well, not strictly, but if somebody has a trademark or a trade name, the person has the right to that name, first and foremost, because that's the law of the country. not NERA law, but law of the country. Once you've gone to get a trademark, it belongs to you. We cannot rule against that. But if you don't have a trademark, and you be used as somebody like for you, that name belongs to that person. So we don't do this based on sentiment, we base things on policies.
You provided a solution for the owner of the trademark. You sold the idea, spent money, and made it available on the internet based on a contractual agreement. Now, and contract, maybe after some years, the owner of the trademark refused to pay you. He is the owner of the trademark, and he wants let's say he needs to renew the domain. For some reason, you are the one that have been doing all this spending of money in Nigeria. You owe this guy so much money and just leave him and move to the next service provider because you know the previous service provider can't do anything. So now the guy leaves you and then go to another company to want to now try to renew the domain, despite the fact that he's owing you. I'm telling you, I'm seeing this based on some of the background I've had. I've had interaction that I had to discuss with NIDA, with NERA, with Draghi for so long, up to where a directive was given from the presidency saying the domain must be returned back, whether the person is owing the amendment is owing the money or not or whatever. So you also have this thing. So I'm glad that you're saying this because when I had some of these issues and I was discussing with NERA and NIDA, it was more like they just simply blackmail you to get back the domain. That's what they do. I'm sure a lot of people who must have experienced this thing. What government will now do is to blackmail you. Some of the phrases was like an individual trying to extort money from a government organization. You know, you hear things like that. I believe I don't want to mention name here, but I know NIDA was involved, NERA was involved. At the end of the day, I was forced to relinquish it.
Please, I would like to advise that when we're signing contracts, which you read very well.
Yeah, no, the contract was signed, but unfortunately, you know, in government, another person came in, and then he doesn't know what happened, and then they said, no, there was fraud, and there was so many things.
Including the payment terms were clearly spelled out?
Yes, the payment term was clearly, you know, the normal thing in Nigeria. So a new management comes in, and then the whole thing is like the previous management were fraudulent. They just simply went to write a contract, and we don't have the money, we're not supposed to pay this much money, and so on and so forth. So, and at the end of the day, government might come on you, and they say, see, you just have to relinquish this thing, you don't have any option.
Okay, since NERA does not have the jurisdiction to sit on some of these things, what we always do advise is that if you let us know, we talk to them and NIDA, and then they'll see what they can do in terms of making sure that at least for the work done, you get paid for the work done. You might not be the one to continue with the contract, but at least for the work done, they will try to intervene to make sure you get paid for the work done.
All right, thank you.
All right, you're welcome. There's somebody there? Oh,
So
you
we'll just
want
take
to...
one more question then. Since they have a stand here, other issues can be discussed with them during the networking.
Hello, my name is Stephen, and I want to know how you are doing regarding DNSSEC, and also a question: how am I sure that having .ng, you people are not using my information, that is the information, browsing information, to sell to those big statistic guys out there?
Okay, Stephen? For 2020, okay? In terms of selling your content, why should we sell your content? We have a data privacy policy. We have policies that govern the way we do our work. There should be some element of trust. We check the background of the staff we employ, and we make sure that nobody is likely to sell your content. No, we don't sell people's content. We protect you because we are the custodians of money. It's equivalent to saying that how can we sell things that belong to our own country to outsiders? No, we don't. Please rest assured that nobody's going to sell your content from the .ng, from NERA. Okay? Thank you.
Thank you very much. Another round of applause to Mrs. Eddie. Okay, so Steve, be assured that your content will not be sold out. If you have the confidence to do with other people outside Nigeria, why should you not trust your own people? All right, another round of applause to her, please. Okay, so we'll take the third presentation of Mid Networks, and he will be telling us about building a scalable backbone transmission network for Nigeria. Please, a round of applause to Ahmed.
Okay, good morning, everyone. My name is Ahmed Atere from Mid Networks. I would like to continue from where we have stopped. I'm highly excited to be here today. And sincerely, we're here to plan what belongs to us. Because for me, where I always give much of preference is made in Nigeria content, made in Nigeria products, and always saying that we Nigeria can handle our things ourselves, which was the initial, the first lecture we had about the IXP, the second one about having our own domain. But the next question to us is this: on which backbone does all these services run on? That is what I'll be taking us on for the next few minutes, and I believe that we would have a very exciting time. First, we'll talk about the background of backbone network in Nigeria right now. We also talk about where we have, how do we move forward from here. Very importantly for me is the fact that all of us in this room were stakeholder to building Nigerian national backbone that is very stakeable. Don't think you are not, because you're not an engineer or because network. And having a robust network also talks a lot more about what the need is. 10 or 15 years ago, I'm sure the kind of phones we are holding is not the same we are holding right now. We now have phones that are that can do a lot more, that require so much bandwidth, and then also require ourselves to be well involved in everything we do. And coming here today, half of us, or maybe just of us, are probably used to Uber. That's a service running on a backbone network. Some of us would have also run on different services. Basically, all we do right now revolves a service that is are here today do register for this conference online, which tells us something. We're moving to that era in which being online is going to be part of all our services. Then, how do we move forward? Looking at the history of some of the services we actually all engage in, I've set up there. Looking at the history, our world used to, maybe they call it the dark ages. But something happened. There was a revolution. And the revolution has turned into something like this. What do we see in here? A connected what? Environment. Connected continent. And the next question is this. How is this continent? How are they connected? That all these continents, they are connected together via a thin strand of glass.
To make this more appreciable to us, this is talking about 4,000 kilometers less than moving around the entire world. That is the circumference of the world, right? Is just 4,000 kilometers less than laying fiber to all local government in Nigeria. That tells us a huge work ahead of us. Now, let's do a quick one again. If on average, we're talking about the cost of deployment of fiber backbone as about 7 million per kilometer, and we have 36,310 to travel across Nigeria. We're talking about a whopping 35 billion capex of doing this across Nigeria. And for foreign partners here, we're talking about over $700 million investment, and it's affordable. Is this guy huge enough? We just want to sit there and allow it done without being a stakeholder in this. Then the next question is, how do we build this kind of product? Let's move on. This is basically like a breakdown of what a typical technology will be looking like. And you can see a huge part of it goes to construction. We also have some part that goes to the engineering, and some part that goes into the staff that will participate in this in this kind of deployment. So if this is well appreciable, how do we all start it? Or looking at the whole architecture, how do we build a scalable network for Nigeria? Now,
For Nigeria.
We need to understand where we are.
Like I said,
Currently,
we have had some appreciable efforts from some telcos who have rolled out fiber optics across the nation, basically to expand their network, being a very cheap means of backbone.
of all the telcos that have participated, as against each of them going was individually on themselves. So let's give an example. If it takes them about, let's say, 45 million the fiber route from the beginning of the end.
So let's give an example. If it takes them about, let's say, a 45 million to lay fiber route from the beginning of terminal to the end of it, 45 million investment is enough to take traffic for all the telcos we have in Nigeria on the same fiber optic cable. We have that same 45 million investment being paid by all the telcos individually. What do we have with that? Over 180 million naira. So it tells us that that is not an efficient way to move forward. So in building a scalable network, you want to build a network in which people can actually share. We understand that some other commercial services in which doesn't allow them to put together some of their network. But eventually, what we're saying is this: we can achieve a lot more if we have voice deployment around. We have several fiber cords. Because I'll give a typical example. We're doing a project somewhere in Cross River State at some point, and while Telco A was built, ironically, it was some issues that happened on site. It was going to affect Telco B's infrastructure. The same direction, they are given the right of way on the same site, and because they are going the same way, one way or the other, one telco infrastructure is going to affect the other, because in the process of manual digging, sometimes, which is the most popular in our country, one can mistakenly damage the other one. So sometimes you have several fiber cuts around. If construction goes that same direction, I remember some years back when they were doing this Lekki Ekpe Expressway, a lot of us who lived in Lagos would have seen a lot of fiber optic cables being damaged, all on the same direction. These are some of the cases currently. Again, we do not have a regulated mode of deployment. So Telco A could do their own the way they like. Telco B will have their own standard, and Telco C will have a different standard. Whereas we can all have a uniform bandwidth to move, or bandwidth, or a uniform way of deploying things. So these are some of the current issues we have in the country. Then again, when a new telco or a new service provider needs to come in, there's a very huge barrier, because he has to also do the same thing, like the example I gave earlier on of laying cable across the Third Mainland Bridge. If he wants to pass that same route, even with his own infrastructure, he has to do the same thing. So these are some of the critical situations. The next question is this. This is where we are. This is where we need to be. How do we get there? In doing so, we need to build a scalable network. And in building one, we have identified 3 major stakeholders: the government, the telcos and the service providers themselves, and also everyone in this room, which I mean all the citizens around here. Let's now take the issue with everyone, one after the other. Looking at the government, so many countries have already done around the world. So it is very important that we actually create a standard in which A, B, C know where they pull in some fiber. But I've seen some deployments done by some telcos in which they're actually using PVC pipes to actually lay in their fiber optic net. The stuff that has been done by the federal government. Sorry, I need to move. Control room. So, and I'll give kudos. Control room, please. Okay, good. Okay, thank you. So, moving forward, we'll give kudos to the Nigerian government. I'm going to get there quickly. So basically, taking a case study of how this works, like an example I was giving earlier on, right? We have in 2003 in Spain, talking about can actually play a major role. And there was a policy that any major building that is being built should actually come in with ICT infrastructure or ICT service or passive dot already in place. Same way we can say that any major estate being built right now should be internet ready, such that any of the telco providers who wants to serve them broadband internet or broadband services can easily plug in. I will tell you what currently operates. So like I said, I work for Mid Network Nigeria Limited. We actually build fiber optic networks for schools, for agencies, for government, and also for estates around. What we have to do right now is, in providing broadband service to every home, we have to also be the ones to go into those homes and actually deploy fiber optic facilities, because when they were being built, none of these homes actually, there's a government policy that as new homes are coming up, there are duct channels, they're actually prepared for the advent of connecting them to the internet services. It's going to be a lot easier to even boost those who want to invest in that case. The second case scenario for that is Ahmadu Bello University. My company actually built the fiber optic network at Ahmadu Bello University. And what we have done, what was achieved moving forward over there was the fact that after the project was about 43 kilometers of fiber optic cable that connects 3 major campuses together. Afterwards, there was fiber to every floor in the university, and we had to land points all around. Basically, what we realized is it was a lot of work because it has all been done. But having had a serious engagement with the stakeholders, it was agreed and a policy was made moving forward that any building that is going to be built in that university should come properly built with the ICT infrastructure. That's an example of a policy that can be made to enhance broadband services moving forward, which is the same thing each and every one of us can do over here. We all have our houses, we all have our homes. It's as simple as even in your homes, you can actually have some internet ports in all of your rooms. I mean, that's a policy, that's something you can prove moving forward, right? So, again, I'm going to share with us right now. Up there we have an example of the Korean government, which through series of phases, trying to move fast on my stuff, they are able to subsidize the deployment of broadband network to all the underserved areas by also investing the government funds through phase 1, phase 2, into those times when backbone is being deployed around the country. And afterwards, you are able to get broadband internet for everyone because what does it? Now, coming back to the Nigerian government right now, from the pronunciation of the federal government about internet to all underserved areas, also local government in Nigeria, in which the telcos, some telcos have been selected, and they are asked to actually deploy fiber backbone around the entire country. And the government is also subsidizing some of the cost of deployment. This is one great kudos. What do I mean by this? And the telcos can come together and save that cost. They will have a joint collective effort to protect used in serving other underserved areas far in the east, far in the west, and we can achieve internet for everyone. So using a shared infrastructure environment, all this is very much possible. And the telcos and the service providers can actually come together to achieve this by having enough planning and also with skilled personnel, which is one major factor I also want to stop and talk more about. We know what currently operates is the telcos wants to roll out. They have award a contract to some contractor who end up giving to another subcontractor and down the line. Eventually, by the time the job is being deployed, what you have in that series is you have, let's say it in a real fact, you have a network that has been built in such a way that you cannot even, they are not up to standards. Because there has been different level of stuff, different level of acceptance, and by the time it comes to what is the world-class standard of deployment, this is not being achieved. There are pictures that could show all that around the country, as you can have sometimes minimum stuff, you have different fiber bricks in every point of time. Even characterization of those fiber optic networks are not properly being done by the time sign-up project is being taken care of. So this is on the telco part. Partner with the government, any major stakeholders, and be able to different ways. For example, limousine, not which the government has factors of the infrastructure, and the telcos actually has 55%. And what have they been able to achieve with this? What they're able to achieve is, with this partnership, the government indexes with the service provider, take fiber to all the schools, to all the government agencies that you have around. And what I've done with my own part of that CAPEX is I've procured a certain level of internet infrastructure for all these schools over a period of time, while you use the remaining amount. So for the telcos themselves, it's more like an assured revenue for X number of years. And this actually helps and improves. So with serious collaboration with the government, the telco, and also the service providers, we can actually achieve a lot moving forward with this. Okay, now back to everyone in this room. How do we move forward? I'm talking about all of us here. And in building this scalable network, we need very, very skilled personnel. I mean, the first thing is we now know what it takes to build. We know where we are going. We know what we want to achieve. We want to have broadband internet around the country. We want to have it to every nook and cranny. We want to have it to every village. How do we participate in this? Obviously, in moving forward with this will not just be built with the with government policies, with the telcos. We actually need resources, which are some of us in this room and some of the other people around. How do we move forward with this? We need to acquire the requisite skilled, that is, skilled engineers who are able to deploy these networks using the proper techniques, what standard, and are able to ensure that what is being built can stand the test of time, as against the ones in which you have stubs that moves in and out, right? And I introduced to you a course in which can help each and everyone in the room, or any skilled engineer who is highly interested in being part of that 250 billion investment that is going to happen in a very short while in the country, plus also maintaining the already invested backbone network done by the telcos. Because moving forward, if we're saying we're doing this and building a scalable network for Nigeria, we also need skilled engineers who are able to support these services, who are able to build it, who are able to plan around it, who are able to get things done. And Kona, basically, it's a course called Certified Fiber Optic Network Associate, which helps in proper planning, proper design, project management, and also maintenance going forward. This is like an old architecture of what is fully required to actually get this done. And this is why I'm bringing this back to us and saying that this is the major tool for us. In doing this, it's basically, it's no prerequisite. So don't see yourself as being too old or too young, or I'm from a different field to get this done. And it's also very important that, what we also found out in deployment all around, which I've also been involved in, is we have the planning team not syncing with the deployment team having their own without the maintenance team, and this kind of puts everybody together to have an end-to-end architecture. Because you can find yourself anywhere else and be able to speak of where are we going, how do we move forward. and also for that does maintenance, and it gives a lot of operational staff tools and techniques on how they need to get and support this skill. Again, okay, Mid-Networks is actually the first Nigerian partner to become an OTT training delivery partner.
Selecting infractors. Infractors are all companies which has been licensed to deploy robotic networks around the entire country, and there are 6 of them. What the government has done is to ensure that they give the government a protection of every local government in Nigeria. And government subsidizing.
What input devices have?
What it basically does is it actually gives them a kind of incentive to go into those areas. And after this is achieved, one of the things that will be the outcome of that is to have a centralized platform network, have a uniform pricing system, and even for the people that are coming in, you can actually have a very, very good pricing.
So traffic streets. What are you showing? Which was 750.
All those ways
okay, now the next thing is the
let me call it transmission. An example is this. Imagine if when Third Mainland Bridge was built, just at the center of it, there's a big duct system that is meant for fiber to be able to travel across. As against what we have right now, maybe next time when you drive on Third Mainland, just look at the side of Third Mainland Bridge. You see some casting just by the side of it that has been done to protect the fiber optic cable that was laid on the ducting on the bridge itself. That would have been avoided if from the get-go we already had those channels that are meant to actually carry optical or network transmission equipment like ducting infrastructure. So one major thing the government can do, policy they can say, which I know in some cases is being enacted right now, surely by the Ministry of Works, is the fact that all roads construction must come with the ducting infrastructure all inbuilt. For buildings, all houses, or for estates, all houses must also come with those ducting infrastructure already inbuilt. Because I'll give you an example of this. When you have a fully tarred estate already in operational, right? For you to start digging or putting a backbone network would cost you more as against when it's being built. So even for the developers, one, it's cheaper for them. For any telco coming, all he has to worry about is to take the bandwidth right to your doorstep, and you already have the channel to go into all the other houses. So all these policies goes a long way in ensuring that the broadband for the internet for everyone, which is the theme of this year's program, is achieved, because there is now a little capex. I was mentioning about sometimes when we had to build para backbone for some of the for like 2 or 3 estates, we have to put in the infrastructure cost. For some campuses, we have to build in that and kind of look at the PPP arrangement to recover our money over time. So, but imagine if during the infrastructure project, you have had all this inbuilt, it goes a long way. Then lastly, before I finish, one major policy the government needs to put in place is the fact that there should be a proper standard, especially for signing of fiber optic projects all across the nation. I mean, telcos build, they come and submit their fiber build and all that. But at every point in time, we've seen a lot of mess that has been done across Nigeria. I mean, it's kind of annoying, which is why we're emphasizing on, you do not just deploy and roll out. Proper planning, proper skilled service are actually required in getting this into place. I hope that has answered the policies question and also the earlier one about the .com.ng.
Yes, and I don't think I will let you answer another question because you will take into all our time. We don't have all the time in the world. Okay. All right, while we wait for Dewale. Dewale, are you ready for us? Dewale? Okay. Ahmed, yeah. One more so we don't deny him since he has one more question. Hello?
Thank you very much, Mr. Ahmed.
Okay, sir.
I'm Ifetayo.
Okay.
You've answered most of my questions, but I want to ask, can we really achieve the internet for all without a constant power supply to all our backbones? Then what will you suggest to telcos in terms of securing their fiber optic cables all over the country? Because you have increased fiber cuts as we talk now almost every second. What would be your suggestion from experience? Thank you.
Okay, thank you so much. Let me start from the first question. Without power, what do we achieve? Let me tell you a little, instead I should not talk so much, but please, pardon me. Let me tell you a little story about what we do, right? In mid-networks, we felt the same kind of problem, right? So there was a campus we actually went into to build a fiber optic network for them, name not disclosed right now. And what we realized is that even the grid that is coming to that campus is almost at zero. The voltage is very low, that it cannot even power up the switches. That's even very terrible. And when you are building an anarchic network in which you have the core, you have the distribution network, and you have the access nodes. Even when the access nodes are down, it means everything goes up. We have to make do what we have. What do we have to do? We have to put up a solar-powered station for all distribution units. In fact, yeah, it's going to increase the capex, but for you to actually ensure you have services all around, that's what needs to be done. And Nigeria is kind of blessed, especially in the northern parts, when you have solar high enough radiation, so solar can be used. Even somehow in the southwest, so we can actually do that too. So what we have to do in most locations is we have to put an alternative backup solution, such that the only place you have to worry about is the end client. Then at that point, he has to put on his own system. Even for FTTH network we have built too, what we worry about is our OLTs in those estates. Once those ones are powered, solar powered alternative backup power solution, then we can achieve it, right? It's a long way, but I know the federal government is actually doing a lot in terms of trying to also, work around the power station. But don't let power be a problem to us. We can actually work around it. I visited a site yesterday, and a client, before I left Abuja, a client was asking me, okay, he wants to have a camera system around his entire estate. And the major problem is that's a very wide expanse of land. And the first question is, There are remote locations. How do you get power? How do you get bandwidth into it? Right now, there are some solar-powered cameras that comes with backup system, come with camera, come with street light that we can actually use. I also come with SIM card. So by default, I can log in with those places remotely and I can put them everywhere, right? So it's not a problem. We've been facing it day in, day out. We have to work with what we have, create alternative backup solution, solar, wind. In Casina, we have some wind vanes powering some of the active equipment over there. Zaria, Bida, a couple of places, we have some power solutions, and that's what we have to do, okay? And the last one, which is about how do we protect ducting system. So in fiber optics, there are 3 major levels of ducting protection. The very first one, which is close to the fiber optic cable, is using what we call an HDPE duct or using a COD system. Those 2 materials I've mentioned, they actually give the first level of protection to fiber optic cable wherever they have been dug. And that is only done at layer 1 when you are able to dig up to a 1.2 meter depth. When you don't dig up to 1.2 meter depth, the next thing for you to do, if it's less than 1.2 meter, is actually to cast on the cable itself, right? You do what we call a concrete slab, such that if anybody is trying to walk around that, they're going to what? They're going to know something is over there. The third level of protection is what we call a warning tape. So even at the first dug of that particular part, where your fiber cable passes, somebody already sees that there's a fiber cable warning along that path. Which is why I always insist for all my clients. In fact, what I get to do for them is to customize warning tape for each client. So if I come to your office and you are XYZ Nigeria Limited, I'm doing fiber cable for you, I will say XYZ Limited fiber optic cable along this path. And we're going to put a contact number. So in case, even if it's somewhere in the bush in Bida or somewhere in the east around Calabar, and someone is just digging and it sees your warning tape, right? The first thing is to actually look and call the number on it. But like I tell you again, that's why we need skilled personnel on site. Because if they are not skilled, doesn't even know what to do. He sees that stuff and it goes on. But someone who has been trained in class or with some certain level of courses will know that, okay, I'm about to reach a fiber optic cable system. The last and the most important one, which is very, very critical, and we also need the government support on this, is just like the map I showed you earlier on, there should be a map that shows the entire fiber route around the country. It's a very long shot, or we can start building it. I know telcos, they also have their map all around. Some of them are geotagged. Some of them have it on their manholes. But all this is very much possible because before you give right of way to anybody who's trying to join fiber optic cable, after he has shown you his path, the next thing is to ensure that you know where it's passing and he knows he must recognize all the existing infrastructure in those locations. Not only for the cable, you also have some underground power cable. You have some, you have some infrastructure, maybe water pipeline, some gas pipeline. That was a project we did somewhere at the airport in Abuja, and you'll be amazed at the kind of armored cable we found underground, and it was not documented. There are a lot of this all around the nation. So we need to actually have something to see what is underneath the ground. And that helps in doing proper scenario. Marga, can I go on or wait?
Yes, thank you very much.
Okay, thanks.
Okay, another round of applause for Anne. Okay, so our next presentation, taken remotely by Thomas Webel of Flexoptics. So he's going to be talking to us about the complexity of hyperspeed transceivers. So this session will try to describe in detail the structures inside optical transceivers, a TOSA and ROSA. Is no longer just a diode in a housing handling the light path to and for the fiber. So he's going to basically try to tell us how the optical industry players around the globe make it possible to squeeze everything into the tiny form factors we see today. All right, Mr. Thomas Webel, are you ready for us? Webel, are you ready for us?
I'm ready. Can you hear me? Can you hear me? Perfect. Okay. Yes. There was a perfect introduction already to myself. I'm Thomas from Flexoptics, co-founding the company 12 years ago, and in these days I'm mainly in the field of optical transceivers when it comes to the technology. what is inside of transceivers, how you can use those transceivers in the network. And so when I started in networking engineering almost 20 years ago, 100 megabit was somehow commodity and gigabit was the bleeding edge. In these days, also Google started to launch their services, and it was basically built on a 100 megabit switch broker 4000. Now, 20 years later, this has changed tremendously. 10 gigabit is definitely commodity. 100 gigabit is getting commodity, and we are hitting the 400 gigabit speed or transmission speed. Now, looking into your networks, I assume the complexity, comparing it with 20 years ago with the complexity of today, it also has changed tremendously. And also that happens to transceivers. So the first 1 gigabit transceivers look quite complex, but now the 400 gigabit ones look even more complex. And that's mainly my talk about in the next 20 minutes, to tell you, to show you what has changed actually. So let's start straight ahead. What I did there, let's see if I get the feedback. Yeah, perfect, this works great. Because I also see the presentation deck here on my computer, which is helpful having some feedback. So what you see here is what I did. I opened up two transceiver types for you. The first one on the top there is an SFP plus 10 gigabit. This is a transceiver which you use heavily in your networks. And on the bottom one, you see a 400 gigabit QSFP-DD. And beside the size, also inside, things have changed pretty much. And what I want to cover in that talk is mainly on that 400 gigabit one is that digital signal processor called DSP, and also those two nice gold boxes, the transmitter and the receiver part. And let's start with the two golden boxes. So first of all, the golden boxes, when we open it up, it's an empty box. And the transmitter part is also called in optical networking or optical engineering, the transmitter optical subassembly. The acronym is TOSA. And the TOSA has a electrical connection to the PCB where we have the DSP and also post-processing systems. And now the box is empty, and you have to imagine this box has a dimension X and Y of 5 by 10 millimeters, so really small. So first of all, we get the electrical high-speed signal in there, and as we're talking about 400 gigabit, we get 4 electrical lanes, each running at 112 gigabit roughly. So first of all, we need to convert the electrical signal to an optical light level, and that's done with laser diodes. And as we have 4 electrical signals, we also have 4 laser diodes who do the conversion. These laser diodes do have 2 main characteristics. The one is they emit light which is not really focused, and secondly, they consume power and current, and this will heat them up. So to keep the laser stabilized on the wavelengths, we need a cooler. And this cooler also takes current to cool down the diodes that they keep their center wavelength. And that's a really important part, that cooler, because when the lasers are gonna drift away and they drift away with the wavelength, your link won't work, or you will have, at the beginning, you will have bit errors, and then later on, the link will drop. And the second thing what I mentioned is the unfocused light, and to focus it, it's pretty much done like people using glasses like I do, is you use lenses. And these lenses, you have to imagine, we have 4 of them. For each laser diode, we need a lens. And these lenses are really small, so X, Y, Z. In dimensions, we are talking about 0.5 millimeter of dimension in all 3 directions. Now, in production phase, those lenses are going to be placed in 50 nanometer steps. That's the first challenge. And the second one is, when you have them in the right spot and when they are focused, you have to keep them there for the next years and decades, because we want a reliable transceiver, or TOSA. So, and this is typically done with glue, which is hardened by UV light. And this glue needs some special characteristics that it lasts there for quite a long time. So you can imagine this is a tricky, difficult process, especially when it comes for reliability issues in the long run. So we have now focused light, 4 wavelengths, 4 colors coming out, but actually they are not hitting the receptacle at the end of our TOSA, of the golden box, where we want to plug in our fiber optic cable. So we need an additional component inside there, an optical multiplexer. And what happens inside that multiplexer is, it's pretty much easy physics, which we all know from a mirror, for example. We have an angle here, and the light inserts into that filter block, and it's a little bit angled, so there will happen a zigzag from the yellow color and also from the red color. The zigzag is going down until to the green color, where we have the output here, and then it's going to be combined, hitting the receptacle, and now we have all 4 wavelengths combined together, hitting our plug. So now the light is on the fiber and traversing our fiber itself a couple of kilometers and hitting the receiver. The receiver, again, this time it's a gray box. It's not a golden any longer, but it doesn't matter. The color isn't that important. It's an empty box again. And so first of all, we have to separate those 4 wavelengths again. And that's done with an optical multiplexer. It actually works the other way around. It separates with a zigzag principle again all the 4 wavelengths. And like what you can see here, we have a green filter. And first of all, the green light is passing that green filter, but the other colors are bouncing back and forward, and always, or when they hit the appropriate filter, it's going to be past that light, and the other colors bouncing back and forward. And so that's how we can separate all 4 wavelengths again, which we need to get again lenses which do focus for our receiver. In this case, it's a pin diode, and this pin diode does the conversion from the optical level to the electrical level, so vice versa compared with the TOSA's laser diode. These pin diodes do have a really low signal output, so the amplitude is very low. So what we need for the post-processing systems on the transceiver itself, or even on the switch and the ASIC, we need an amplification of the signal to boost it up, because otherwise the post-processing system couldn't handle it. One side story here is about the amplifier. When you're operating 10 gigabit, for example, long reach or very long reach ZR transceivers with a power budget of 23 dB, and you connect them back to back without any attenuation, you might have recognized, oh, the link worked for a couple of seconds, and then suddenly the link dropped. And then what happened there, you overloaded the transceiver, actually the receiver, and you broke the receiver. But what you actually broke is the amplifier. You didn't break the diode. The diode is still fine, but the amplifier got too much current in the input side, and it actually broke. So that's somehow a side story here. So because quite a lot of people always think they break the receiver itself, but actually the receiver is still working. It's more the amplifier which is broken. So when we move on, so we have now the TOSA and ROSA produced and the setup, and now it comes to the assembly of the overall transceiver. And I don't want to dig too much into the overall production process, because this would extend this talk way too much, and you guys would be starving, having no lunch. So what I took one specific finding of the production, which I think is important to know, which is the timing. And interestingly is to see there, it's the comparison of the testing and the assembly. So I have here on my graph, on the x-axis, we have 3 generations of transceivers. So we got 10 gigabit, 100 gigabit, and 400 gigabit. And on the y-axis, it's the timing in minutes. The 3 graphs are typical, basically the assembly, which is the blue one. You see it here, We got the bold green one, which is testing, and the combination of green and blue is the orange one. And for sure, we're looking at 10 gigabit transceiver. When we produce them in batches and do also testing in batches, we are talking about roughly 8 minutes of everything together. There is, on the assembly, there is a rise of the timing going up to roughly 15, 20 minutes for 400 gigabit transceiver when it comes to the assembly, which is quite obvious. More components in there, more precision, higher density, which is straightforward. And yeah, but the interesting part is actually the testing. When we look at testing, the rise is way steeper comparing it to the assembly. So testing a 400 gigabit transceiver in a proper manner is roughly 90 minutes. And this, when we see how this curve is going up, this is has a big impact on the production. Also, when it comes to testing time, and this consumes costs at the end of the day because of expensive test equipment. But that's also a way how you can cut down costs. And the challenge there is to cut it down without cutting down the quality or the result actually of the tests. And I think this graph gives a good idea that the main task of building a 400 gigabit transceiver, beside all the R&D and the development, is at the end of the day mass production, the testing, and not the assembly. Okay, I introduced at the beginning, beside the TOSA and ROSA, I also introduced the DSP, this digital signal processor. It is new introduced for 400 gigabit when it comes to pluggable modules. DSPs have been around for a while, but on pluggable modules, what my talk is about, it's very new. This DSP has mainly two functions. It first of all takes care about the modulation. I don't want to talk about modulation in this talk. And it has a second function about the forward error correction. About error detection itself, we already are familiar with it. We're looking at 10 gigabit, for example, on an Ethernet frame. There is the cyclic redundancy check at the end of a frame. And with that CRC checksum, basically, you can detect errors, but you can't correct it. And the forward error correction can detect, and as it says the name, it can also correct it. And that's really important for 400 gigabit, but it's also important in some circumstances for 100 gigabit. The new thing now is at 400 gigabit, this is done inside of the transceiver. So how does this typically works? Let's start with the 100 gigabit one here. We have a switch on the left side, and inside of the switch we have forward error correction. And then it hits somehow the fiber, the line, and on the other side, it also gets to the FEC decoder, which does the decoding then. Looking a little bit more precisely into that, it looks like this analogy example I made here. The lorry itself, on the first step, is our FEC encoder, and the payload, which are the bricks inside of that lorry, is our payload. And on the second step, when the lorry hits the dodgy road, somehow all the bricks are disordered. Even one brick, like the blue one, is lost. And on the right side, we have the excavator, which is our FEC decoder. And he brings all the bricks back in order somehow of that lorry. This takes a little bit time, and that's one drawback of a FEC. It has a delay actually of 100 nanoseconds when you enable it in your links. So that's important. And like the excavator, he consumes diesel to operate. Also a FEC inside a switch, it consumes power. And so it's always, if there is a FEC not needed, better do not turn it on. But yeah, because it consumes power and adds delay to your link. But there are circumstances where you're definitely going to need it. Now looking at 400 gigabit, and there it becomes more complicated, is instead of having only the FECs on the switches, we now have the FECs inside the DSP, inside the transceiver itself. And how does this work? It's like this. So the switch FEC does the encoding, again, like in 100 gigabit. But now the FEC inside of the transceiver needs to decode it. And then does it encoding again, brings it on the fiber on the line, and on the counterpart, The FEC on the transceiver itself does the decoding and then encodes it again for the switch FEC. So now we have 4 FEC 4 pieces in place. I'm not quite sure if you still hear me. I see now something different happening here on the Zoom app. Please raise your hand or say something if you don't hear me any longer. I've just double checked the chat here. If there is some new, there is, oops. Is there the chat? Don't see anything. Okay. Seems to be all right. As I said, we have a couple of, we have now 4 FECs in total, and there are actually 2 major important things. First of all, when you operate a 100 gig or 400 gigabit link, and you need to make sure, let's say 100 gigabit link, and you have bit errors on your line, you better double check the FEC settings, because in some circumstances the FEC is not enabled by default, and that's typically done by the switch based on the type of transceiver which is plugged in. It does it automatically. So like a 100 gigabit SR4 or CWDM4, the switch should actually enable the FEC, but in some circumstances it doesn't do so. So you might end up with bit errors on the line, and because the FEC is not enabled. So enable it, and most probably all the bit errors will disappear. And the second one, this is getting more tricky and more complicated also with the 400 gig, is when your link is not established at all, because you might have enabled an unequal amount of FECs. Like in this example, the Bobby car is way too big for that tiny excavator. It can't be handled. So if you would have enabled the FEC on the left side on the switch and transceiver, but on the right side only on the switch, for example, this wouldn't work at all. And that's really important to know. So always have an equal amount of FECs involved, 0 to 4, and double check the settings if it's needed or not. Okay. What is new in that field out when it comes to high-speed transmissions? I always give at the end a little bit a overview. What we are currently testing in the labs is 400 gigabit LR4, and there is really one important thing to know about LR4 at 400 gigabit is that it's still not defined yet by IEEE for which wavelength grid they will go. Quite a lot of people assume it's going to be the LAN WDM 5 nanometer, which is known from 100 gigabit, but there are also attempts to go for a CWDM4 wavelength grid having a spacing of 20 nanometers of each wavelength, which is for LR4 quite new, but it's it has some advantages compared to the LAN WDM when it comes to production and production costs. And IEEE hasn't defined yet which standard will, how the standard will look like for that spacing, and we are also focusing on it, how LR4 will be defined then at the end of the day. We are currently testing LR4 as CWDM4 wavelength grid. Let's see how the tests go. The same we do with 100 gig ER4 and ZR4, and that's pretty new actually, is having a longer reach now, up more than 25. Actually, ER4 is 40 kilometers and ZR4 is 80 kilometers without amplification straight out of the optic. And that's pretty new because 100 gigabits seem to be stuck somehow at 25 kilometers, but with the latest development, we get ER4 and ZR4, and that's pretty cool. Lab testing is ongoing in these days, and hopefully we can publish some results in the next couple of weeks. Beside that, we see a movement in the 5G rollout with 50 gig Ethernet, which might be interesting in terms for the data center operations because of 2 facts. First of all, 50 gig Ethernet is cheaper to produce compared with 100 gig. And second, and there will be high volumes also on that field because the 5G mobile network operators are focusing on it. And secondly, the ASICs inside your switch, for example, you have a 400 gigabit switch. The ASIC is basically capable to handle 50 gig. And it even can handle more. It can handle the 400 gigabit, 200, 100, 50, 40, 25, 10 gigabit. So it's a really multi-speed ASIC. And the only thing is, or the only question is there, how will the network operating system of the switch will handle those speeds? Because currently they are not designed or not built for the 50 gig Ethernet. Let's see how the future move there, and this might be an interesting opportunity or an interesting alternative compared with the 100 gigabit transmission if it's not needed and 50 gig is enough, then this might be a cheap way to build somehow data center interconnection if you only need 50 gig. Secondly, on the DWDM side, we do already running DWDM, 80 channels up to 11 dB power budget with a speed of 25 gig, or even up to 40 gig as a QSFP plus form factor. That's a single wavelength technology here, which is pretty nice and can be used on existing filters, which is great. Right. This brings me to the end of the presentation, and I hope the audio worked well. In the middle of the presentation, I didn't see any picture here on the screen any longer. If there are questions, for sure. And maybe I'm not quite sure about the audio, if it's working well incoming to me. Maybe Devole is gonna repeat on the microphone. Thank you very much.
Right, thank you very much, Thomas. Thank you for the wonderful presentation. So, do we have any question for him? Questions? Right. Thank you very much. Okay, so we're going to take the next presentation, which will be done by Edward Banjo from Layer 3. He's going to be talking to... Yes, question. Okay. Sorry? So he's going to be talking to us about SD-WAN, what it is and why we use it someday. All right, a round of applause for Banjo as he walks in. Hello, Banjo from Layer 3. Please, a round of applause for Banjo as he walks in. Thank you.
Okay, so this is to go forward. This one forward and this backward. And this big button? Okay. Okay. Thank you very much. Just waiting for the technical folks to
right, thank you very much. Okay, so just like I was introduced, my name is Edward Banjo, and I work for a company called Layer 3. And I'm just going to be talking about SD-WAN. What is SD-WAN and why we should, why it's a trending word now in the industry. In the ICT and in tech, one thing we realize is that at every given time, there's always going to be some trendy topic. And SD-WAN, for the past 1 year, 2 years, or even more, it has been trending. Okay, what is SD-WAN? Basically, the definition is software-defined wide area network. Now, I know a lot of us here are in the IT space, and for those of us who don't know what a wide area network is, I will just a wide area network, why we need a wide area network in the first place. So why do we need a wide area network? The primary purpose of a wide area network is to connect users to their resource and applications anytime and anywhere. For the context of this brief, we'll be using an enterprise wide area network. The purpose and network of an enterprise would look like. Now, typically, in every other branch office. So looking at this diagram now, typically the HQ would have all the application, all the resource the organization would need, and they don't need to replicate it in all the branches. And the branches will still have the same level of productivity. And I'll just is, and not just for banks, for enterprises as well, who perhaps they will need to operate in different locations in the country or even in the region. And the resource that they use, the applications, would just need to be in one site, typically the HQ, and every other branch can take advantage of that. So where all this basically in a very is concentrated in a server room, or you can call it a data center, where all this resource will be concentrated. Now, so if you just want to look what is actually in this server room or in this data center, typically that is where, I just put a lot of logos together, some of the database. You can find your Microsoft Active Directory. I've worked for organizations whereby these things are just resides in their HQ, and everybody take advantage of this. In some cases, the network access control comes from the HQ, the accounting servers. There are some antivirus applications at the time that you have to, it gets installed in the HQ, and every other remote user has to then connect to it to take advantage of these services. So basically, it's fair to say that wide area network itself has actually made businesses more productive, especially in centralizing their management, the ICT infrastructure and investment, and without necessarily replicating this investment in all the other branches. But you know what has happened? Now that we have virtualization, what has happened is what I term the cloudification of enterprise business applications. They need to be installed on the hardware in a data center. They are now virtualized versions of these services. Now, if we have virtualized version of these services, some forward-thinking companies like the likes of the Amazon, AWS, Microsoft Azure, and Google Cloud could actually think that, you know what, why don't we have a service whereby rather than these people have this thing in a data center where they actually have to pay money to actually run this service, why don't we just allocate a virtual instance for these people, for customers who want to use it, and let them install an instance of that service on our cloud platform? I mean, things have changed these days. I remember if you want to install Microsoft Office, you probably get a CD, and after internet connectivity, you can just get your Microsoft Office downloaded. Things have changed. I remember there's a company I worked for once. Part of our service offering was to centralize all your ICT resource in our data center so you don't have to have it. And if I open a rack for one of our premium customers there, you'll see a lot of labels, accounting server, this server, that server. You could imagine the amount of energy, the amount of power it was consuming. But with the introduction of virtualization, these services don't necessarily have to be on a physical device anymore. So, so everybody is going to the HQ to get data that resides on the HQ. The branch offices go to the HQ to get these services. Now, typically, the technology which they would use to get to the HQ is some sort of wide area network technology like MPLS, which is being deployed by a service provider. These branch offices would have internet breakouts and that is taking me to the HQ are now being can virtualize this application and have it in their cloud, which we have to get through the internet. So like I said before, we might be struggling to make a case for the conventional wide area network that is deployed. Is this. They all have virtual instance of their device. So basically, the Juniper, for example, their firewall was SRX. Once you just put V in front of it, VSRX, you know they're talking about the virtual instance. The Cisco ISRs too, we have virtual instances of these devices. So now, let's have a look at this. First of all, the software-defined site-to-site wide area network. Now, from what you can see, we have a mixture of a conventional underlay, which is the internet and MPLS. And on top of that, with the help of the SD-WAN CPEs, which in most cases are virtual, we create a path, a wide area network from one branch to another branch. So we can transfer, communicate resource over the underlay, which is the internet or your conventional MPLS network. A virtual tunnel, that's the SD-WAN, is created. A virtual path is created, and we can do exactly what we used to do on the physical circuit, but now software-based. Now, in most illustrations of SD-WAN, you will typically see that in the diagram, they will still put the MPLS circuit there, even though we are saying we can leverage strictly on the internet. Because hardly would you find an organization right now that have totally abandoned their MPLS circuits. However, they are gradually, most of their day-to-day resources going through the SDM path on the internet rather than the MPLS. So this, for now, you still see it's typically going to be a hybrid network. So with SD-WAN, you can see as depicted there all these. Hello. Sorry about that. So now, like I said before, if a lot of these OEMs, like your Cisco's, your Junipers, they have virtual instances of their routers. Some of these, your typical networking functions like your firewall, router, even application-aware services, your UTM services, everything can now be installed on a virtual instance. Now, if you now have the likes of Amazon, Microsoft, and Google giving us opportunity to actually host on their infrastructure, what is actually stopping us from then going there to install an instance of a virtualized Cisco router, Cisco firewall, a Juniper firewall, or Juniper router? So technically, we now have a router in the cloud. So say, for example, I'm hosting some of my services in Amazon. I've got a mail server. I've got some sort of cloud infrastructure that is facing my customers. At the same time, I want it protected. I don't need to take a physical router and a physical firewall there. I just have to install a virtual instance of this. And quote unquote, I have a router inside Amazon's cloud. Even though it's not a router, it's a virtual instance. Now, say some of my services are also being hosted in Microsoft Azure. Now, they've given me a VM. I can install I have some sort of database service which I'm offering to my customers, but at the same time, I want to install a firewall to protect them. Then who do I want to go with? I like Juniper. You know what? I'm going to install a virtual instance of Juniper SRX over there. And guess what? Technically, I have a router inside Azure's cloud, even though it's not a physical router. So the term they normally use, they call it site to multi-cloud. So basically, all the branch offices, they have routers. The company has routers inside these cloud services. So these are one of the advantages of SD-WAN. Do you understand what I'm saying? And because they are virtual, they can be sprung up easily. You know, it's not a case of you want to buy a device, you want to spec it. Then when you now spec it, you now send it to you now send it to where it's going to be installed, and you start working with some engineers. You know, how are we going to install it? It's all virtual, and it gives us a footprint into the cloud, these cloud providers, and you know, we have what we call a site cloud to multi-cloud network within our local physical network. We extend our wide area network into a public cloud, and that's one of the advantages of SD-WAN. Okay, and I mentioned one of the terms of SD-WAN, and that was the orchestrator. Now that's cut across all the OEMs that offer this service. Now, for those of us who know, who are network engineers, who know your typical router has two aspects: the forwarding plane and the control plane. Now, the way this works now is with the virtualized CPs, the virtualized firewalls or routers over there, they only have the forwarding plane now. Now, the control plane aspect has been relinquished to the orchestrator. So what happens is this. The virtual instance is deployed on the server in a branch office or in the cloud, or it could actually be a hardware. Some of the OEMs that offer SDN service can actually give it to you as a hardware, which you find typically in a customer's premise. But when it's in the cloud, then you know it obviously is going to be a virtualized form of it. Now, the routing configuration and all the policies would actually be domiciled in the orchestrator. Now, as long as there's an internet connectivity or there's a network connectivity to the orchestrator, from there we push services to all the branch offices and even to the virtual router in the cloud. Just as simple as that. Just as simple as that. So the routing decisions, the policies, because some of these CPEs, like I said before, they have what I call application-aware services, QoS, just like your normal firewall. So if it works that way, all the configuration comes from the orchestrator, and it's just very, very seamless and very, very straightforward. So why SD-WAN? Okay, so for every single buzz, every new technology out there, there's always something they'll be pushing out. The OEMs who are offering to sell this. Number one, you hear is that it would save cost. Now, how would it save cost? Typically, to be very honest, the cost-saving aspect is people would say you don't need to subscribe to MPLS anymore, and you can just pretty much take all your services via the internet, through the cloud. That's one aspect. Now, also, as I mentioned, springing up instances of virtual routers would be cheaper to deploy than a hardware sending an engineer to site. In those two aspects, that is one way you could definitely save costs. Now, with reliability and productivity, from the previous slide, you notice enterprises who are actually deploying SD-WAN are still using a mismatch, a hybrid. They still have a hybrid WAN, internet and the MPLS. Now, for most of the SD-WAN CPEs, end user device, they have the capability of integrating both your MPLS and your conventional WAN technology MPLS and your internet service. So depending on the policies you have placed on the orchestrator, you can say, look, we realize that through the internet, getting to certain application is quicker than through the MPLS network. You can just say, you know what, take it through the MPLS. So it has some sort of quality of service, which is where the reliability and productivity comes into play. Now, it is easier to spring up. I mentioned that. And there's another term you hear a lot in SD1, and that is ZTP, zero touch provisioning. Now, if all the routing and the firewall policy is not actually on the device anymore, it's coming from the orchestrator. So what do you actually really need to configure? Nothing. As long as those CPEs can reach the orchestrator, it just pushes the config to it, whether it's a physical device or a virtual device. And which pretty much the last point there just highlights what I've just said. It is easier to manage. It is easier to control. And of course, for data analytics, you want to say how many people is logging in or the threats. Some of these CPs have firewall capacity as well. So from one central point, you can pull out all the data that you need. So okay, I think there's still a slide. Next slide, please. I think there are 3 more slides after this. Okay, so now, some of these new technologies, you find that there's always a buzz, there's always a craze about it. And sometimes I'm always very, very concerned with how well they are being adapted to, who's actually subscribing to it. If you've been long enough in this industry, sometimes some of these services, some OEMs are not 100% ready to they're not 100% ready to deliver this service, but just so that people will know that it's something they're also discussing about, they'll start making a lot of noise about it. So a survey was done in the US in 2017, and basically it's a SD1 adaptability survey. Well, how many of us are using it? Who is thinking of it? Now, let's just say for the sake of argument, it was done in January 2017. And 29% said they've deployed already, or they're going to be deploying it in the next 12 months. So which means still using the analogy of January. So by 2018, these 20% of these companies have actually deployed it. Now, 30% said they are still considering it, they are still thinking about it. Now, the last one is quite important. And that's why I said for a while, we'll still have a hybrid, SDN, internet, then the conventional MPLS. So 62% of them said in the next 5 years, they are still going to be deploying the conventional MPLS wide area network. And when you talk to a lot of engineers, especially in countries where this technology has been adapted real quick, they will say they still don't trust the reliability of SD1 as far as critical data is concerned. MPLS has worked fine for them, but I think gradually we'll start to see that more and more companies will start to adapt this. And if you ask me, what even made SD1, gave it the audacity to even come as a technology, is because over the past 10 years, 10, 15 years, all around the world, including Nigeria, the affordability, the availability, and the reliability of internet services has improved. I mean, we all remember the time of internet cafe. As a matter of fact, I know somebody who built a house based on the business of internet cafe. I don't think that is a lucrative business anymore. Internet has improved over here. In countries like the UK, in America, most of all these telcos are doing more and more investments. I remember in the UK then, getting 8 meg of broadband ADSL internet in your residence would cost you like 15 pounds. So, but now everything, you can get more bandwidth, and the things we can play around with in the internet has improved. So this is a service we actually provide as a company, and we are providing it through 2 of our partners. Juniper Networks, and VMware. Thank you very much.
Thank you very much, Mr. Banjo. Okay. So we'll take, I don't know if anybody has any question. We're already behind schedule. Just one question, please. One question.
Thank you. I'm Abdul Fatai. I have more than one question. Okay, so my first question is that if I'm looking at deploying SDN, how do I deploy SDN on my intranet without even going to the WAN? That's the cloud service. Then two, what if the orchestrator goes down because it's centralized? What happens when the orchestrator goes down?
Okay. Can you repeat the first question, please?
Okay. The first question is, you talk about SDN, that's the software-defined network. Mm-hmm. Then you said the SDN1, and mostly for the multi-cloud service. What if I have a huge campus network and I want to deploy SDN on my intranet?
SD1 on your intranet.
Before being SD1 now, on my intranet, not going outside.
Oh, okay.
So how do I go about that? Then the second one was for the orchestrator, if it goes down.
Okay, so your first question is this. It's possible. What are you looking for? What's going to be in your SD, in your software-defined network? You need a router or firewall. Well, you go with whatever OEM you want and get the virtualized instance of that. What else do you want? You want your storage, your servers, your application. Yeah, all of them can all be software-based as well. Do you understand what I'm saying? So, in case if the orchestrator goes down, well, it wouldn't bring the entire network down. Do you understand? I haven't actually, from all my my research and my own hands-on, I haven't come across that scenario. But basically, part of the offerings is that the installation is redundant.
Very much. Please a round of applause to Edward. Thank you. All right, please, we sincerely apologize for running a bit behind. We'll take two more presentations and we'll break out for lunch now. Okay, the next presentation will be done by Ade Shinya Omololu from Minwon. He will be talking to us about under the sea and on the land, enabling Nigerians' digital space. All right, a round of applause for him, please.
Good afternoon, everyone. Okay. Good afternoon, everyone. My name is Ade Omololu. I'm from Mayone. So the theme of today's conference, is Internet for Everyone. And I looked at it and wondered what's a better way to deliver this presentation. So I'll be speaking about enabling the Nigerian digital space. Briefly, the table of contents, we'll do a short video, talk about the African position on the global map, briefly describe the submarine system. Then we'll discuss the internet penetration in Africa and in Nigeria. Then we'll talk about the Nigeria digital space. Then a brief discussion on the mobile internet traffic. Then the contribution of my organization to, the internet penetration. Just a few 90 seconds to watch. Okay, so that video is not playing. All right, okay. Unfortunately, the video is not playing. I'll start by this data. Looking at this data, you will see that you see where we are in Africa generally in terms of internet penetration. Today, this is January 2019 data, and if you look at it, you see that Africa still lags behind. Talking about internet penetration. Behind Southeast Asia, you actually see that Africa is the least when we talk about internet penetration. Except for South Africa and North Africa that are relatively doing better. But talking about West Africa, we're doing just a paltry 41% internet penetration, and East Africa is a lot worse at 32%. I wouldn't want to, I mean, the data for Central Africa, obviously, I believe that it's highly related to the unrest that is happening in Central Africa. But, I mean, that is not to say that they are doing well. It's a 12% data penetration in Central Africa. So juxtaposing that, try to do an analysis of 2018, 2019, where we're coming from, where we are today. And you see that in West Africa, we've only been able to move by a 2% increase between 2018 and 2019. It's not good yet. But the most astounding stats that you have there is what you have for East Africa, and I think they've done well in East Africa, looking at the fact that they've moved 5% and they're still growing. However, if you look at the data for North Africa and South Africa, you see that it's been stagnant over the course of 2 years, and same goes for Central Africa. What that speaks to, in my own opinion, is that you've gotten to a level of saturation, and most likely the urban areas are already saturated. The urban areas in Africa are getting saturated. And you see another stat specific to Nigeria that will show that. So what do we have? We're social. I mean, it's a common stat site. So this tells us that depending on who you believe, I mean, there's a stat that says that we're a population of 200, and there's another that says that we're a population of 180. But this says that we're 198 million population. Now, looking at the Nigerian population, if you look at the number of internet users in Nigeria, we only have 50% internet penetration in Nigeria. Now, there's an interesting stat. If you look at 50% internet penetration, compare it to the mobile subscribers that you have in Nigeria, you have a total of 75%, give or take, mobile internet subscribers in Nigeria. Now, the best form, and you see, the best form of enhancing internet penetration and getting internet to everyone, in my own opinion, I think it's going to be largely powered by the mobile operators. And you'll understand why I'm saying that. So today we have a total population of 198.4 million, give or take. However, out of that 198.4 million, you have 51% urbanization. That is to say, 51% of 198.4 million lives in the urban areas. Now, if you look at the population of the people that live in urban areas, and you compare this population side by side to the total number of active mobile users, you can see that the total number of users in terms of, look at the total number of internet users that we have at 50% penetration. You can see that it's closely related to the number of people that we have living in the urban areas. Now, what that tells you is that largely our urban areas too are gradually getting saturated. If we're talking of getting internet to everyone, then the earlier we start moving to the rural areas, the better for us. However, at what costs are we going to deploy these services to the rural areas? Right? Look at the total number of active mobile internet users. Now, talking about mobile internet users, of the 50% internet users in Nigeria, 90.91 million of that are on the mobile phones. Now, what does that tell you? That means out of the 50%, 46% of that is via mobile. So eventually, the extent to which we can attempt to get the internet on the hand of every Nigerian is likely to be via mobile. So this data just tells you that we've grown in Africa, and that's the truth. I think it's a plus for us. Between 2015 and 2019, it tells you that we've had about 45% growth in Africa. But looking at where we're coming from and comparing the African continent to others, we are not there yet. If you look at the past data, you have Europe doing about 90% penetration and Africa just doing about 40–45% on the average. However, we've grown. I mean, if you look at the growth rate in the last 5 years, we've grown. We are all aware that this growth, and I mean, let's not be deceived, this growth is largely powered by the submarine cable landing in Nigeria and in the coast of Africa recently in the last few years, right? And you just have very, very few of them. So largely, I think the cable companies have helped in doing this. Terrestrially, obviously, the mobile providers they've done well in that. However, linking Africa to the internet has been largely powered by the submarine cables, and you see that. So I'll just briefly talk about the contribution of this. So I work with a company that is also into submarine cable, and this graph just tells you where we're present at today and how we've tried to also improve on the internet penetration. So today we serve countries along the coast of West Africa, and I think if you look at the growth rate that we've had in that region today, we do traffic into Togo, into Burkina Faso, and the coast of West Africa, Chad, and the likes. However, that's talking about the other countries. Now, let's look inward into Nigeria. Ahmed came up the other time, and Ahmed was talking about what it takes to build fiber across Nigeria, and he was talking about that building fiber across Nigeria is only 4,000 short of building fiber across the world. 4,000 kilometers short of building fiber across the world, and that is true. However, today in Lagos, I think there's, and generally across Nigeria, I think there's a fundamental problem. I think there's still an infrastructure problem, which I will talk about. But what we have today in Lagos is a coverage of about 450 kilometers fiber around Lagos. Now, that's not much, and we can still do better, right? However, like Ahmed discussed, what we've seen is a lot of providers channeling infrastructure, channeling cost into building separate segments of fiber. And really, I don't think that will work for us in a long time. So also we have an extension into Ogun. We have about 372 kilometers into Ogun, and also Edo State. Now, that's talking about where we have fiber. But looking at it, what do we have to do to get internet into every hand? There are two sides to it. One is the terrestrial, but the other one is bringing internet closer to Nigeria. What can we do to bring internet closer to Nigeria? And I think today, compared to where we were coming from, if you look at it today, looking at the top 10 sites that Nigerians go to, this graph tells you about the top 10 sites that Nigeria go to. The interesting thing about this site is that the hosting providers, likewise, the interesting thing about this is that 7 of these sites today are hosted locally. So that means, in a way, we're getting there, but we're not there. We have tried to bring internet closer to Nigeria by bringing those locally. So we have 7 of these hosting sites provided locally. But that is talking about bringing internet to us. Also, in addition to that, Jacob came here and spoke about the exchanges. And I think the exchanges they've worked fantastically. We've tried to interconnect. You have IXPN, you have the gigs, you have WAFIX, and I think the exchanges have worked good. However, there's still a challenge. The challenge is the last mile. How do you get people to cross over that last mile to get access to all this infrastructure? So talking about the limitations that we have, I don't think it's new that we know that the cost of delivering fiber still remains a great challenge. Today, I think in Nigeria, if I understand, I know that challenge seems to have, for microwave deployment, I think there's still the sanity in there, in the sense that you have just few players delivering the microwave tower and a lot of people collocating on it. But that is not happening in the fiber space. What you see in the fiber space is everybody digging ground and laying fiber. And I think we need to move away from that. We need to go to an era where you can have one party or multiple parties delivering fiber dock, and there's a leasing of fiber. I think it was Ahmed that spoke about it. And I think this presents an opportunity as well as a challenge. It's a challenge today, but I think it presents an opportunity for anybody that wants to take advantage of that, to work in collaboration with the government to deliver this duct, and we can have people leasing off it. Also, in addition to that, my time is almost up. In addition to that, I talk about the right-of-way. The cost of right-of-way today predominantly is transferred to the user. And there's no way, World Bank's projection for us to grow was at 8% GDP. I think that was about 5-6 years ago. Now they're talking about growing at 2.2% GDP. That continues to reduce the wallet share of every Nigerian, which in turn affects the ability to get internet access. If this right-of-way cost continues to increase, eventually the whole vision of getting to deliver internet to everyone may not be achieved. So there has to be a way out of this. My first slide that talks about the collaboration is a simple way. Just have one duct. Have one duct and have everybody lease. You can have multiplayer, it doesn't matter, but not that everybody continues to dig ground whenever they want to lay. In conclusion, I strongly believe that our aim of delivering internet to everybody is largely dependent on how cost effective it's going to be in the future. We cannot continue the way we are going now and expect that we will deliver internet to everyone. It won't happen. So we need to change our model. We need to change our way of thinking. It has to be more collaborative, the way we approach infrastructural development in Nigeria. And I don't think we've done that. The cost of delivering these services are huge today, and they are much, right? And it shouldn't be the responsibility of individual organizations to carry this cost. And I think there has to be more collaborative. Service providers need to collaborate more and deliver on this. That's the only way for me that I believe that we will be able to achieve this. Thank you. One other thing that I would want to mention is also that I had a chat with Mukong just before I stepped on. And I want to say that here because of, I believe there are industry leaders here too. Our adoption of IPv6 is paltry, really. And sooner or later, when we run out of IPv4, we will have to move to that level. The earlier you take up that challenge now and start learning the IPv6, the better for you. Thank you very much. Okay, so that's it. We need to demystify IPv6. Thank you very much.
Right, thank you very much. Ololu from A1. It's interesting to know that 7 out of the sites we visit around the world is local to us in Nigeria. Is that correct?
Absolutely.
Right, so please a round of applause to Nigerians. We're doing well. Then we need to take it to the next level. All right, the next presentation will be done remotely. So I don't know, one question, so we'll do same that we did to other people. Just one question. Yes.
Thank you very much for that wonderful presentation. Okay, looking at, you made a suggestion about looking into leasing or creating a fiber optics network, and you could lease it to some service providers. So how does one curtail vandalism in that regard? Because it could be a very huge problem when you've laid all the wires and everything is ongoing, and some people somewhere just decide to take a chunk of it. How do you go about curtailing vandalism?
So curtailing vandalism may not be it may not be a reality in the very near future. But I think just like what is happening in the microwave space today, if you don't need to have just one player. If you have 2 players and you have 2 ducts or 3 ducts, but not more than that, but not necessarily managed by the telcos, managed by a third party, and you have telcos going through leasing each of these ducts depending on what they want to use for redundancy, they don't necessarily need to pass through the same fiber path, right? Absolutely. So in that case, except if vandalism is intentional, you understand? You can't do anything about it. But destruction of fiber ducts because of construction and things like that, I think you can limit the damage to the barest minimum. If it's intentional, there's nothing you can do about it. I'm sorry. There's really nothing you can do about it.
All right, thank you very much.
All right, thank you.
Okay. So another round of applause for him as he leaves the stage. Okay, our next presentation is supposed to come remotely, but since it's not ready, we'll be taking the one from Nina Baggington from Netflix. She'll be talking to us about localizing Netflix content in emerging markets. Localizing Netflix content in emerging markets. So this session focuses on how the Netflix CDN called Open Connect works and how network operators can collaborate with ISPs and IXPs and IXPs to bring customers joy. All right, Nina, if you're ready, please come to the stage. So once her presentation is over, we'll try to see if the remote person is on. Otherwise, we'll just break for lunch. I'm sure we're all hungry. I'm also hungry too. All right? Okay, sorry about that. They said the remote person is ready. So he'll be talking to us. His name is, he will be discussing taking advantage of cloud computing in Africa. That will be done by Danny Afahunko he'll be talking to us about taking advantage of cloud computing in Africa. So Dewale, if you're ready, please, can we go?
Hello, can you hear me? Hello? 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 Okay, yeah, it seems like I cannot hear myself, but okay, let's go. My name is Danny Afanko, and I'm a CEO founder of Cloud Inspire, a company based in France. I'm a cloud solution architect. To give you a quick summary about my background, I've been working like a system engineer for Afrinic before moving to France, like senior cloud solution architect. And now I'm a CEO founder of my own company promoting Ahome, a tool that aims to simplify all the journey or all the process of going to the cloud system. So the idea of this small interview or this small talk is only to give you a clear vision of what the cloud is it really about, and how we can take advantages of the cloud system in Africa. So we'll go through the different through this agenda. What is the cloud? What are the type of cloud? The service that the cloud provides? How to build the cloud? The concept that is quite important here, and then what we can build cloud solution or cloud infrastructure in our Africa region. So the cloud is what? Cloud is only an abstraction of IT environment. So we need to make sure that we make a clear separation in the term. So when we are talking about the cloud, we are talking about environment, a place where we can run application. So when you're talking about the cloud computing, is an act, a function of running a workload in the cloud. And then we have now the technology that are the things, that are the toolings, the software and hardware used to build and use in the cloud. By saying that, we have cloud, different type of cloud. We have the public cloud where all the life cycle, the bare metals, or all the materials, all the infrastructure is owned by someone else that gives you only the ability to run your network or your system inside his infrastructure. So we have the public cloud. The major one are Amazon, Azure, Microsoft Azure, AWS, Google, and now we have Alibaba, and I think many more will come again. And then we have, on the other hand, what we call the private cloud, where you have everything located internally inside the user, data center. Almost everything are on-prem, and the user is responsible of having his power, his connectivity, and everything related to maintain the service up and running. Then you can have a kind of a mix in between the two systems, where you have the hybrid, we call it the hybrid cloud, where you have something in between the public and the private. Then you can separate your system in between the two systems. And then you can have also the multi-cloud, where you have more than one public or private cloud. Then you can work on many systems. Then we are talking about multi-cloud. So what are the kind of services we have in cloud? The major one are what? When we are talking about infrastructure as a service, what we call EIS. It is deliver what we call the compute, the networking, and the cloud storage to the user via network connection. And we have also what we call the platform, is like when you have only a software platform that runs. Like, I don't want to know exactly what is the basics of the machine. I just want to have an application that runs. So I will have a kind of a platform. It's like I don't need to know if it is Ubuntu, CentOS, or Windows that run my application. I just need to make sure that my application is running. So I will use the platform as a service that this cloud is provided to me. Then you can go even beyond that, having kind of what you call a software as a service, where you have a working application. A working application can be a summary of the platform and infrastructure as a service, where it delivers a computing, a networking, a cloud storage, an application on top of it. So I want to have only a service. The service can be like, I want to have, let's say, a cluster of a Kubernetes machine. So I will have a storage, I will have network, I will have a compute, and then on top of it, I will have an application that will help me to run my network, having a kind of service. And this service is managed by the provider, and I just need to make sure that the service is running and I can just use it, consume it. So if that's the case, we can go even beyond, having like everything as a service, where we have almost everything like you want, you just name it as a service and you put everything there. And people will say, oh, do you want to say that if I have a cloud system, is it only about having a hosting system or hosting services? Yes, some people will tell you yes, but really I will tell you no. Is something different. So what really changed? When you are talking about cloud system, it's not only about hosting an infrastructure or service. It is about the mindset. It's about how you design, how you are perceiving your network, or how you operate your network. It's like you need to enforce, strengthen the way you plan your system, you design, you code, you build, you test, you release, you deploy, and you operate. And everything needs to be automated. You need to break down your system in small pieces of application that are quite autonomous, and you can manage it through API. So the API is quite important in cloud solution. And during all the life cycle of the platform or the service that you are deploying, you need to make sure that there will be no human intervention. This is quite also something that is important, to ban the human intervention during the life cycle of the system that you are putting live. Why? Because we know that most of the time, all the outages are coming from the human intervention, coming from the changes that we don't master. And then we help you also to avoid repetitive tasks and annoying admin tasks. And finally, you need to make sure that you can be empowered the end user through what we call a self-service portal. Give to the end user the ability to run whatever he needs to run without having to ask you about something. So you give to the user, to the end user, the ability to create his own network, and he can be kind of autonomous. So building a cloud system, in summary, it is a methodology that strengthens, that put emphasis on process, when we have the agility and DevOps culture, automation, the continuous iteration of testing changes and deployment, automated the provision of quick scaling, using a lot application, the API, application programming interface, and microservices, and give what we call the self-service portal to the end user, and you should be able to also to do what we call the chargeback, and know exactly what your system costs, actually, to put a price on your system. So there's not only a single way of building a cloud system, a cloud architecture. So based on your need, based on how you perceive your system, you should be able to create your own cloud environment. What are the basics? It is only to having a kind of operating system. It can be Windows, it can be Linux. And then on top of it, operate, like using a tooling that will give you abstraction and have your tooling for your virtualization, your containerization, and have your machine on your devices. And that's it. So we will not talk about the cloud system, about how they are built off, but we will talk about cloud system, what they can do or what they are providing to you. So the cloud is only about strengthening the process. What is important, strengthen the process, automation, and have a tooling. Building cloud in Africa. So why in Africa we can take advantage of cloud system? Why we should all move to cloud? Why? And when I say move to cloud, I'm not saying put your data to Google or put it into Amazon or put it into Azure or even to Alibaba or something else. I'm talking about why can't we build our own system, we can have what we call hybrid or private, where the entire system can be under control, or even at least the most sensitive parts of the system can be under control. Because now, and having those kind of system and taking advantage of the cloud system will give us ability to have a kind of accurate documentation, strengthen the process, automate all the steps before going to live, reduce human error, master the changes, and to be able to revert back to the well-known state if something goes wrong. Go live stress-free. We all know that before going to production, people are scared and crossing fingers. But if you are in the cloud solution or cloud methodology process, you should be able to go live stress-free, because you know that you are in control of whatever is happening. If, for instance, something goes wrong, you should be able to revert back and go to the well-known working state. So you are confident going live. And you should be able to reproduce your system and debug it before going to production. And what is quite important here is to be able to standardize your deployment process across different environments. So the way you provision your system in the dev, the same way you provision the system in the QA, in the qualification environment, the same way you provision your system in production. So it gives you ability to make sure that to prevent kind of outages before going live. If it's not working in dev environment, for sure, it will not work in production. So there's no need to you for pushing in production if something breaks in dev or even in QA. And it reduces also the system troubleshooting time, because sorry, 5 minutes left, so I'm almost done. Don't worry. It reduces the troubleshooting time, because you know exactly what is going on. And of course, it gives to the admin the ability to hand over a lot of tasks and give it to the end user, and they can focus on something more interesting about how they can improve their existing system, how they can make it better. So building a cloud system is only about, nowadays, tools are quite mature enough to have a cloud infrastructure. To build infrastructure, we need just to follow the cloud philosophy, to be able to create a system that is accessible by other computers through a network, have your repository of IT resources, and you should be able to provision your system and scale quickly and via automation, of course. Now, I'll give you a list of tools that you can use to build your cloud system, at least your private cloud system. And then you have, for the containers, I will not go through all the details. So we can have maybe next time a deep training about how to use all those tools together to build your system. But here is only an overview of tools that you can use and put together to create your cloud. Do you have question? And you can find me at ahome.africa. And thank you.
All right, thank you very much. Okay, so we'll send, Dewale will be sending you the next question, so we can have 1 or 2 questions. So if you have any question, please send it, Dewale will ask him. Okay, so our next presentation will be taken by Nina, and she'll be talking to us about localizing Netflix content in emerging markets. Please a round of applause for her.
Hello. Oh, is that a clicker? I promise I will be brief because lunch and I am hungry. So we'll see. I'm here today to try and talk to you about OpenConnect. OpenConnect is the CDN for Netflix. And Netflix, as you know, is a video service provider, also active here in Nigeria. So we'll talk about a little bit how our streaming is working, and first of all, a little bit about how was the internet previously and how is it today. As other people today have mentioned on the stage, in the old days, internet was some global providers, some regional providers, and then the ISPs who were selling internet access on the bottom. And then the data would be flowing bi-directional, but it would flow up to the tier 1s and down again to the ISPs. Today, things are looking a little bit different because we are a number of people who have a lot of traffic going in one direction. And peering have come in and bypassed the global providers. So today we have content providers, cloud providers, and internet exchanges changing the directions of the flows on the internet today. So Netflix is part of this new way of a new architecture. And what we did is that we decided to build our own CDN so that we can optimize that for the Netflix service. And a quick reminder on what is a CDN. Well, a CDN is some logic, and it's a bunch of servers where you have the files that you want to access. Our CDN works that we have all the intelligence is hosted in the cloud, as we just heard about how you can build your own cloud. We're using the Amazon cloud to have all the intelligence behind the Netflix service and behind the Netflix CDN. Then we have our own servers sitting all over the world. And when a client, so when you is having your device and you want to watch a Netflix movie, there's a communication going on between the client and the intelligence in the Amazon cloud. And then the client eventually is told, go to this server and download your movie. And then first at that point, the client talks to the actual Netflix server. This is a map of where our servers are located today. All the green dots are servers that are standalone servers inside ISP's networks. And the orange dots are point of presence of the Netflix network. This is the Netflix network that is connecting all the orange dots on the map before. Anyone say no? And as you can see, we have one point of presence in Africa, which is in Johannesburg. and a few points of presence in Europe and a little bit more in the US and a couple in Asia and Latin America. So when we have a Netflix point of presence, how can you connect to Netflix? Well, we have an IX site, and at that IX site, we can connect directly or use an internet exchange. But the way we always connect is we're using a peering connection. So we had the first presentation of today was telling us about what is peering. And basically, it's when we are connecting, when there's a mutual interest and a mutual benefit. And that is the only way we do connect to ISPs. It can happen at an internet site, and then we send the traffic to the ISP, and the ISP then sends the traffic through their network into the end users. Another way we can do that is still connect, if it's possible, at an internet connection site. But another way, but in addition to that, we can give the servers from our CDN to the ISPs, and they can place them locally in their own networks. And that way reduce the traffic that is hauled through the backbone and through the network of the ISP. This model can also happen when there is no IX site, but then the servers will then go over the internet. Obviously, we can do this with mobile providers as well. And again, when we do this, the movie is just, the traffic is going the same way. We have 3 types of servers, and something went wrong with the last photo in the presentation. I'm sorry about that. But we have, the middle server of this is a standard 2U server, what we call it, and it's filled with hard drives, with spinning drives, and with flash drives, and that is our standard building stone. Then we have what we call flash servers, which is a very high volume server where we can push a lot of bandwidth out of a very small server. We have these and those can be used when we have a very high demand. And the only storage that are used in those servers is SD drives. And then the last one that's on this slide is what we call a global server, which is a smaller version of the storage server that we're using in low volume markets. So these are the 2 first ones. And we have a lot of spinning drives in the storage server and SD drives in the flash server. So the ones where we have the spinning drives, we can have the complete catalog. And the servers, the ones we're using today, have a 40 gigabits per second bandwidth. And we just have a shitload of traffic and a lot of drive. In the flash servers, we only use the most popular content. So we have analytics that are showing us which movies we pretend we know will be popular the next day. And we make sure to store those in the SD drives to make sure that the servers are as efficient as possible when we actually serve the traffic. That's about 7% of our total storage, but it's 60% of our total traffic on a global basis. So, while you see, because we have this knowledge about what people are watching, we have a good prediction of what they watch tomorrow, which enables us to actually go make sure that the movies are on the servers before there is an endpoint. So here is from a server. We have above the server line, that is the served traffic, the streaming traffic, and below the server line is filled traffic. So we fill during the night. The server is not very busy serving anything, and then we have the full capabilities from the server to serve during the nighttime. So that's one benefit, it's more efficient. Another benefit is for the ISP that have this server in their network. the traffic going to the server is now going in the middle of the night and not during peak hour where the network is busy doing other stuff. So to illustrate also the whole why are we caching, we are only sending one version of the file into each network, but then a lot of people can watch it. Again, the fill window, it's a 12-hour long window during low traffic hours, and it enables us to, another benefit is because we know what people want to watch, we can also produce quite a high offload. So in many markets, we can stream around 80–95% of the traffic from the localized servers, and only the peak will be coming from outside the network. The load balancing helps, and again, popular content on the flash drivers, and we read and write outside of peak. Sometimes we can also have a little bit of an issue using this technology for our CDN, and that when it comes to low traffic markets. Because we want to put all the movies that we believe that somebody want to watch in that market the next day, if you work with a low traffic volume, filling the server with those movies might be much more data than the server would actually be serving if we put a server into the network. So this is a consideration and a discussion we always have when we sign up new partners, is how much traffic do you have? Will we be sending more or less traffic into your net, more or less data into your network if we put a server there or not? And then in collaboration, we figure out whether it's a good idea or a bad idea to work with a Netflix server. Sometimes we can break people's network by doing this. Finally, a little bit about what is the benefit for the quality if we are able to put servers closer to the end users. This is a study from India. In the beginning, when we were active in India, the average distance from clients in India to the Netflix CDN were around 7,500 kilometers. But over time, as we started deploying servers into India, the distance dropped down to 700 kilometers. And what we can see happening is at the same time, the bit rates, the average bit rates of the streams that people were watching in India went up as the distance went down. So we often say that for streaming, latency isn't that important, and that is very true, but it is a little bit important, at least when you come to the difference between 7,000 and 700 kilometers. Again, on more parameters, that reduction in distance also reduced the rebuffer sessions, and it reduced the medium play delay, so the time it takes before the stream begins when you press play. Finally, I want to talk a little bit about what kind of technology we're using with our streaming. So we're using adaptive streaming, where we're trying to take the network conditions into considerations. And in reality, you can illustrate it by looking at the buffer. So in the Netflix client, we have a buffer, and the buffer is being filled by downloading on the network, from the network, and it's being entered by the streaming that occurs on the screen on the device. And the buffer level is what is monitored all the time. So if the buffer level drops too much, that means that the network cannot download fast enough to provide the data that's being played. So we swap down to a lower bit rate to make sure that we can always fill the buffer. Then the quality becomes a little lower. Then the buffer starts to fill too fast. We can pay more than we do, and then switch off a bit rate to a higher bit rate to increase the quality when it's possible. So when we are looking at what quality is being streamed all the time, it is always a balance between how long do we want to wait before we start playing, what quality do we want to be watching things in, and what is the risk of having a rebuffer session. So what nobody wants, I don't want it, I'm sure you do not want to have the little spinning thing going. So we're trying to avoid that. We also want to make sure that things start at time and that the quality we're watching is good. The last thing we're working very hard on trying to improve is the encoding. So we used to do what we call per title encoding, and we would take a movie and we would say, okay, this movie should be encoded in these different bit rates, and then we would encode the whole movie, and then for a certain resolution, we would have a fixed bit rate for the whole session, and then switch between that. At some point, we decided that's not a very good idea, so we started chopping them up into smaller bites, and then just do one piece. So we're doing it per scene now, saying this scene for this resolution should have this bit rate. And that way we are enabled to have a lower bit rate while still maintaining the same or the better quality. So to explain this graph, we have the bit rates on the x-axis, and on the y-axis we have what we call VMAF, but it is the video quality measure that we're using, which is a combination of subjective and machine learned quality measures that we've worked out actually works pretty well. So over time, we then use the AVC high, and now we're optimizing the VP9, as it's called, which is our latest encoding, where we are managing again to squeeze down under 500K and still maintain a very high quality. So if we are lucky, I am at the end of my presentation. Yes. 65. There you go. That was too far. Any questions? Here's a question.
So we'll have a lot of questions. Any question?
Nina, thanks a lot for your helpful presentation. This is Franz from Google. I know that I stand between you and the lunch, so I'm going to be brief. You had a slide about your point of presence, and you had one in Johannesburg for Africa. My question to you is, what are your plans to expand, if you have any, within the continent, and at what time frames?
So it is true that on the map there was one point of presence in Johannesburg, but if we go back to the oh, sorry. If we go back to this map, you can see we have a number of green dots in Africa. So the strategy that we have at this point in time is that we are providing servers for ISPs who have enough traffic, so that for ISPs where we will not break their network if we put a server into their network. So there's a number of green dots. There's a couple here in Lagos as well. And what we're looking into is to do a similar model with internet exchange points, but building an actual POP outside of Johannesburg is not on our roadmap for right now, because the business case for us simply cannot meet with the prices for transport and the prices for hosting to build a fully scaled POP with the activities that we have in the market. But I think we are at a pretty good step ahead by working with a lot of the providers, and both internet service providers themselves and a couple of regional carriers as well. And the next step is to increase our presence at the internet exchanges. Any other questions?
Any other question?
There was a gentleman down here and a gentleman over there.
Right. Thank you very much. One of the challenges we have in Nigeria is our internet is metered, even the internet we have in our residence. Unlike, say, US, where you're from, or in the UK. At home, once you pay, you have unlimited. So I think one of the challenges Netflix might have, because the latest data suggests we only have maybe like 55,000 subscribers in Nigeria. And I don't think it's a true reflection of the internet penetration here. Is there a way Netflix can partner with local providers? So a Netflix data subscription could be a one-off. So we don't have to pay the Netflix subscription and at the same time, our data is being consumed. I think if we could address that, you might have more subscription in Nigeria.
Well, thank you for that advice. At this point in time, we don't have enough activity in Nigeria for our business development team to make that kind of agreements with partners. It is something that we sometimes do in other parts of the world. But I want to say to the providers, you know, is it really a good idea to have these high data prices if you also want your customers to actually use the network? And one thing that we're doing to help on this problem is, one is that we localize the traffic into Nigeria so the providers do not have cost bringing the content into the country. That should help on what they need to charge the end customers for the data. Another one is reducing the bit rates, as I was talking about the encoding. The bit rates that are needed to have a great Netflix experience, in particular if you're watching on your phone, is very, very low these days, which will save on the end user's bill. As we said, we need 64% less bandwidth today to watch the same movie and the same great quality that we did a couple of years ago. The last way to help is that we have a download function as well, so that you can go to a Wi-Fi area or to somewhere where, or you can download at, if you have out of hours prices, and download your movies at that time. So there's a number of the ways that the consumers can come around the cost, but it's also a little bit up to the providers to think about, if we want to sell internet, should we also encourage people to actually use the internet? And doing that, you can do it by pricing. And we had a gentleman down here who, wait, there's some question here.
Thank you. I have a similar question, please. My question now is that if we have content that was on Netflix right here in Nigeria, we have content on Netflix right here in Nigeria, and we have places where we have high traffic of people that use the internet. Will Netflix be willing to collaborate and bring their servers down to Nigeria? And if possible, also reduce the cost of accessing such content?
I am so sorry. I really can't hear what you're saying.
Okay. Let me break it down this way. If we have our own content, I want to go to Netflix, and we have high traffic where that content is going to be accessed here in Nigeria. Now, I'm now saying, will Netflix be willing to partner in bringing down their servers to Nigeria and reduce the cost of accessing such content?
So you're asking if we have?
Question is that, is it possible that Netflix will collaborate with those who have content to put on Netflix and then bring a server locally for them?
Okay. So no, we're not working that way. So what we're doing with content from Nigeria is that we're looking at content from Nigeria, just as we're looking at content from all over the world and deciding, is this something we want to have on our service? Can we license that to put on our service? We already have Nigerian content on the service that we're showing not only to Nigeria and Africa, but to all over the world. So that is one way we're working with the local community here. The other way we're working with them is that we're also looking into, as you know, we want to make new content all over the world, including in Africa. So we have in our content team both a director responsible for licensing and a director responsible for international productions out of Africa. And they are working on finding the great stories that are made here and put them on our service. So you cannot come to Netflix and say, can we buy access to your service and then we serve it from here? That is not the way we act. Our CDN is not a CDN in that respect. It's only used for Netflix service, but we are consuming and showing content from Africa to all over the world. So the collaboration we're looking for right now with the internet service providers is to make sure that we can localize the movies we have, which are both local movies and movies from the rest of the world, into their networks. Questions? Other questions? All right, lunch. All right. It is lunchtime.
All right, thank you very much, Nina. That clap is not so. Please, a round of applause to her. For keeping it's almost on time. It's lunch time. Yes, almost lunch time. We'll have 1 hour, 30 minutes for lunch. That will be lost. Because of the time, we don't have 1 hour, 30 minutes. So we'll just break for 30 minutes for lunch. Is that okay? 30 minutes for lunch, then we can come back and proceed. Before that, we got this from Facebook. For those who love games, please a round of applause to Facebook. For the game, and this will be won by somebody. I don't know who the person is. Maybe it's me, of us, or you. All right? So the done by Mr. Olusegun Oyetunji from Airtel. He's going to be talking to us about software-defined networking. How does it impact traditional IP networking? Please, a round of applause for him.
Hello. All right. Okay. Hello, everyone. So I want to believe lunch is not disturbing us yet. All right. Okay, so it's all still in the spirit of automation. I saw the last presentation, which was pretty good. What are we still talking about? I believe there was a presentation this morning about SD-WAN. How many of you were in the presentation? So I can know where to skip and where not to skip. Okay, great. And I would also like to know my audience. How many of you are networking guys who do OSPF, BGP, all the likes, and or maybe you do anything internet services? Just let me see. Oh, great. So my presentation is here to tell you why you should learn less of BGP, OSPF, and let's move into something else if we have to stay relevant in the future. Okay? So, great. So I've chosen this background because it reflects what I want to talk about. The spider spinning a lot of web. Let's go on. Okay, great. It's not picking. Yeah, it's not picking. So let me just correct the technical bit. Sorry? Apologies for the bit of technical issues. All right. Okay, so as you'll be aware already, we are on a very fast lane of evolution in the digital world. Now, many questions are popping up, especially 5G IoT, massive connections. In 2025, we're thinking we should be 25 billion connected devices, 1.2 billion 5G users, right? How will networks ensure ubiquitous connections? When we talk about networks in this context now, I'm talking about traditional network. How will OSPF, BGP, MPLS, and all the likes ensure all of this? What about cloud? High efficiency. We are deploying cloud everywhere now because we want the high efficiency, you know. Everybody's going into cloud. Enterprise solutions, we're all going into cloud. 100% enterprise solution expected to be in the cloud by 2025. And artificial intelligence, 86% of enterprise expected to adopt this. Do you think traditional networking will give us all of this solution? We'll find out. Let's go on. Next slide, please. So what's the way out? Now, what do we require to be able to cope with this fast evolution in the digital space? We require some intelligence, automation, very low latency, and large capacity. Now, the solution we are looking at here, we're looking at how to make the network have an intelligent brain. Let's take a quick look at our normal protocols today. How do they work? They actually work in a very passive mode. You know, you configure them, and then when anything fails, they automatically, you know, shift to the other side without taking any input from you again. Am I correct? That's just how it works. There's no intelligence in space. Now, but if we have to keep up with the number of connections we are looking at, we need to bring a bit of intelligence to actually make things work faster than usual. I'll give you an example. So if we set up a network now, and I have a connection towards Abuja, another connection towards Benin, okay? I've configured everything, MPLS, fantastic, you know. Then I lose the connection towards Benin, but the connection towards Abuja is already congested. Do you think my current protocols will be able to figure out that that thing is congested, don't shift the traffic? It won't. It will just automatically shift it. That's the way the protocol works, isn't it? So that means we need a better solution than what we do today. Okay. All right, so we need to actually bring analytics, which will actually give us the intelligence. How are we going to pull the data of the past to be able to predict some intelligence into the future? Great. So today's traditional networks, you know what it is? Everything being in the vertical, say you have a Cisco router, a Juniper router, everything having their control, the forwarder, and all of it. So you keep the brain in each physical box. And that's the way we work today. I'm sure you log in into each router to make the configuration change, right? And that's how it works today. Okay, so what does that take away from us actually? That means that I can't do beyond what my OEM gives me. I can't do beyond what Juniper gives me in that box. Am I correct? I can't do beyond what Cisco gives me in that box. That's just it, right? And also, I cannot ask the box to do beyond its physical compartment. Whatever I put in that box cannot be known by even the box just beside it. You know, there's a bit of constraint here because we cannot go beyond one physical box. So how do we plan to go now? We need to have a control plane split. We need to split the control plane from the forwarding plane. So we need to take the brains of those boxes away from these physical boxes and bring them together where we'll be able to control multiple devices with one brain. And that's the whole bit of SDN. Okay. Let me go back a bit. I don't know if you saw that. We also want programmability. We want to bring programmability on board. Now, this is how it works today. So you see, my packet goes from box to box like that, control plane, as it is like that. Now, where do we want to be? We want to be here. Take away all the control plane and the features from all these physical boxes. Let's put them in a central point, you know, could be in the cloud, could be any central point in the core, in the DC, name it. And what do we want to achieve with them? We want this control plane to actually take full control, give instructions to this forwarding plane. That means I'm no longer dealing with vertical boxes. I'm dealing with multiple boxes at the same time. So back to the example I gave the other time. If I lost the connection towards Benin, from the central point, from the control plane, I can see there's congestion out there. Don't move the traffic this way. I'll just program it. Don't move the traffic this way. Rather, move the traffic through Asaba and find yourself in Abuja. Isn't that better? I think that's better, right? Yeah, you agree with me. So that's the whole essence of SDN. We want to shift the control plane, separate it from the user plane, which we call the forwarding plane, and let's have, you know, a central point where we can program the control plane and let it pass out instructions to the forwarding plane. You'll see more benefits very soon. Makes it more interesting, actually. So now, this is just what I've been telling you about. So we have brought the control plane, which we now call the SDN controller. Now, that brain I've been talking about, taking the control plane away from the distance, is what we call the SDN controller. That brain now, the control, SDN controller. And then we still have our forwarding switches. And of course, you cannot part SDN from NFV because these SDN controllers themselves, you deploy them in the cloud, you know. So I believe the person that took the session on SD1 mentioned a lot about orchestration, right? Yeah, orchestration. Because I'll give you a very simple example I saw in 2014, which dazzled me, you know. In the telecom space, we have some boxes that we use for mobile data. And one of it is called the SGSN, GPRS support node. Okay, this is where we all connect to. And normally, when we're deploying this thing, it takes about 3 months. We put in the card, we do this, we run the cables and everything. But with the cloud platform, and before I go on, when you deploy this and it runs out of capacity, they bring in a new card for you, right? You go to site, you plug in the cards and all of this. And when orchestration was brought in, do you know what happened? When that SGSN ran out of capacity, an alarm was generated. And when the alarm was generated, it was passed on to, you know, something we call the OSS, Operation Support System. And then that communicated to the orchestrator that, hey, I need you to add one more virtual machine to this SGSN to actually scale it out, expand the capacity. I'm just bringing you to terms with orchestration, okay? And Immediately that instruction was passed to the SDN controller. Yes, it took the instruction, checked whether it had resources. Yes, I have resources. And then it added that capacity to it. And PIM, all of it was done. Now imagine, compare that to, I'm giving you the card. Please, can you run to Abuja? Take a flight. Please, get to Abuja, put in the card. When you put in the card, put in the cable, and all of this. Oh my, you can never compare the timing, right? So that means it brings us a faster time to resolve things, isn't it? So that's why you cannot part both of them. So in the SDN space, just what I've described to you now is exactly how it happens in the SDN space. I have a use case where I'll actually bring this to context. I'll show you that. So what are we trying to achieve in the service provider SDN? In the service provider, we always say we have the access network, we have the transmission network, and we have the core network. The transmission network is the fiber network, as you know it. The IP core network is where we have the routers and switches, the backbone of the network, and also the access network where we have our radios, or the metropolitan network, as some fondly call it. So what are we trying to do? We are trying to control everything end-to-end with one brain, the SDN controller. Can you see that? The SDN controller. That's what we are trying to use to control everything. The optical space, the WAN space, and of course, the IP core space, all with one brain. Now, do you know, let me make you understand this a bit. In a typical telecoms network in Nigeria, this actually, all these three parts I've mentioned to you, what makes them up is thousands of routers, actually. I'm not exaggerating. It takes about 2,000 plus routers to actually make this space. Now I'm telling you, I want to control of this with one brain. How many, if I should ask you, how many engineers do you think can manage 2,000 routers? 5, 10, 100, 200? I believe you agree with me that it's in hundreds, right? 100, oh, you're not agreeing with me. But in tens. Okay, no problem. So, but, I mean, if I'm to allot you routers that please manage these routers, I'll give you maybe 50, you know, or maybe give you a geographical area that manage the northern part of Nigeria for me, right? And that could be maybe 400 routers, you know. But now we want to have one person sit around an SDN controller to control the space for us. But don't get me wrong, a network like the big ones we have in Nigeria would definitely not have one SDN controller. We can have multiple for geo redundancy, okay? Okay, so what are we bringing on board? The key concept which we're trying to bring on board here, programmability, app-aware networking. App-aware networking. The networking as we do it today, the best we can do is to use source IP, destination IP, and then say if you're coming from this source going to destination, please go this way, right? That's the best we can do with networking today. But now we want to go further. In the OSI layer model, we want to go to the URL level. App-aware networking. That means if you're using Facebook, please route its traffic this way. If it's using Google, go this way. If it's using Netflix, go that way. And you see what makes this more interesting. Now, why are we going to do that? From the telecom space, I'll tell you why. Now, this is the without a network without SDN, where we have no flexibility. So we manually provision the chains, statically defined, just what I've told you. If you're coming from this source, go to that destination, just take this path. Now, we also have the virtual resources or physical partitions of whatever servers we have in place. And then we cannot dynamically switch subscribers, because the best I can do is say that all the subscribers coming from this or using this access point, just go this way. We can't dynamically make switches, you know. It's very difficult with our protocols today. You could see that in a typical service provider network, we have something we call the DPI, deep packet inspection, where I'll actually check what are you really doing. Is it Instagram, is it Facebook, or this? And we also have the URL control, that's the parental control. I don't want my child to see X videos or whatever it is. You know, caching, I want to cache the content of Google, Facebook. CGNAT, you know, I want to NAT it before it goes NAT from private to public. Now, is it everybody that needs this? In today's network, I make everybody go through it. Why? Not everybody needs it, actually. But why? I'm constrained by the protocols. the protocols we use today, the OSPFs, the BGPs, and everything. I'm just constrained by it. So I make everybody go through it because I don't have a choice. And so before you know it, we start buying bigger firewalls, bigger DPI solutions, bigger parental control solutions as the network grows. So what is SDN going to avail us of? So let's see. So with SDN, look at what I'm going to do. I told you about half-hour networking the other time. This is called the service chaining, where I create flexible chains for each person. Follow the green line. If you follow the green line, you'd see that that traffic is not going through all those components. It's only going through the caching. Can you see that? Follow the green line, you see that it goes through the caching. Follow the orange line, you see it bypasses the caching. Give you an example. So if I'm a postpaid user, I just pay flat rate for your data. I don't care whether you charge me separate for Instagram, for Facebook, or whatever, you know. Why do you need to take me through the DPI to know what I'm doing exactly? Since you are being paid anyway, right? So I can save a lot of resources on the DPI box. I don't need to take you through DPI. You're a big man. You're a premier user, you know. You don't need to go through the DPI. And look at that. Look at the orange line going through the DPI, the parental control, and also the NAT. So that means that I'm talking about a kid whom I bought a tab for. So you bought a package for your kid, trying to use it. So I'm able to know from the network that this is a kid who needs to go through parental control solution, block the content is trying to see that are not permitted, and also go to the DPI, and also I NAT him to the firewall. How much saving do you think this will bring to a telecom operator like us? A lot of saving, actually. A lot. So that means because we're talking millions of subscribers here. So if I can cut down 2 million of my subscribers from going to the DPI, wow. I can use that DPI for another 10 years maybe, instead of expanding it in 2 years. That's the beauty of SDN. So what are we talking about? The open interfaces it brings. So you see that interface between the SDN controller. The SDN controller takes an instruction from other components in the network, which informs it that this guy now, this subscriber now, is doing this content. Create another chain for him. So as a subscriber, I can have 5 different routes. As against in traditional networking, where I'm a subscriber, you only take me through one lane. Because you can identify me with my, what do you call it, my IP address, right? Great. So let's move on very fast. So all these are, so the most important thing is I'm able to discriminate layer 4 to 7 now, and also embed traffic classification, dynamically switching between different chains, okay? Now, this is a big point. Before SDN, what can I do? I'll have multiple vendors in the network, some covering the IP cores, some covering my transmission. If I have an enterprise customer who says, oh, I need a connection from Lagos to Abuja. Oh, I'll tell my IP core, please create this for him. Oh, my transmission guy, create that for him. You know, it takes weeks before this coordination comes into place and I establish the end-to-end connection. But now, with SDN, that enterprise customer just needs to go to a portal, make the request. That is passed as an instruction to the SDN controller operator, who then, you know, tells the SDN network what to do. And it creates that slice of the network for my enterprise customer. So that means I'm bringing a job of weeks into maybe hours or days at most. But how is that guy able to do it? Programming, not configuring OSPF, BGP, and all the likes. You know, now Python is a very powerful tool that is being used to instruct the SDN controller, right? So great. So that means that I'm now having what do you call it now? A unified bearer, a cross-domain coordination, yeah, between the access, the transmission, the core. I'm having a cross-domain coordination because all are controlled by the single SDN controller, right? So quickly, I will not waste the time on this because I'm actually running out of time, but this is the typical use case where I have a CPE device at the customer end, and what can the SDN avail me of? So now, before, we have a lot of functions sitting on that CPE device, the DHCP, security gateway, the IDP, and all of it, name it, you know. And whenever this enterprise customer has grown, I may have to replace this hardware. But now I'm shifting all of these functions to the core, and I'm only using the CPU device to give connectivity. Every other thing controlled from the central point. And so where does that take us to? That means that CPU device, I can use it for years instead of maybe more time, because it's just a bridge anyway. Yeah, so quickly, the cloud controller does the orchestration, and then the SDN controller instructs the cloud controller of what to do. So if the customer has just come, I need a firewall function, then the SDN controller informs the cloud controller, and the cloud controller adds a VM to it. Now, okay, so, and the CP, I just told you, it just gives connectivity. I'm skipping fast because we're running out of time. We don't want to keep you waiting here. So yeah, this is the steep curve that we are actually going to. So where are we heading in networking? I told you don't need the OSPF and the BGP, you need to dwell less on them. We need to look into the future. So where are we heading? Where are we right now? We are at the software-defined network with automation. You've heard a lot about automation today, right? So we are at the automation point where the SDN controller automates a lot of things. Okay, so what does that give us? Agility. We are now very agile. We can do a lot of things in a very short time. And then we have a central control. Okay, well, what's next? Intelligence. There's something after SDN, and it's called IDN, intent-driven networking. How many of you have heard that? Okay, intent-driven networking. So today in SDN, what are we doing with SDN? SDN is helping us configure, right? But we are telling SDN what to do. So we tell SDN what to do, SDN knows how to do it. Not these two words, what and how, right? But with IDN, IDN knows what to do and tells SDN, gives SDN the instruction. And SDN says, yes, I got your instruction. I know how to do it. So take an example. You have artificial intelligence in networking, and then it says that, okay, around December, people normally travel to the eastern side of the country. I know, I have the history, So when they get to Onitsha, network is always congested. I need to split the traffic in Onitsha. So he knows what to do, right? And he just passes that information to SDN. SDN controller, please do it. Wow, that's less of a human intervention, isn't it? Great. So you can see intent-driven, model-based, multi-layer, and we are bringing network intelligence. So with that intelligence, we can be able to handle big data, AI-based networking, and predictive maintenance, just the one I told you now. It can predict, where there will be issues based on historical trends. That's bringing artificial intelligence. But what's the ultimate point that we are getting to? Autonomy. When network will run with zero-touch operations. Somebody's asking me, so what are we going to be doing after this? That's a big question. But, as the network keeps evolving, we will also evolve, right? So that's why I'm challenging you today. Don't dwell on the traditional networking so much anymore. Add a bit of a skill, a bit of programming. Become programming savvy, SDN savvy, and prepare for the future, because we are actually going to treat the big data. Remember those first three questions. How do we address the AI? How do we address the cloud solutions? How do we also address the billions of devices that will be connected by 2025? Okay, so are you ready for 2025? Are you going to glide on the high waves of networking, or you are going to be like this guy? Don't be like this guy. Okay, so ready to take your questions, please.
Question, are you ready for 2025? Sometimes when these things come up, you ask yourself, I think I have a knowledge gap. I need to go and close the gap again. All right, we take one question. Any question for Mr. Tunji? Any questions for him? All right, so another round of applause for him. Thank you very much. Okay.
Yes, I have a question.
Okay, can you hear me now?
Yeah.
Okay, my name is Jacob from Internet Exchange Point of Nigeria. Your presentation is fantastic, but towards the end it becomes scary. Like, I'm going to lose my job.
No.
Okay, but the thing is, so for network engineers that are seeing this now, what are those things that you think that they can start working on to actually meet up this 2025 goal. That's one. Then two, I don't know if you have information on how much are we catching up with this software-defined networking system in Nigeria at the moment?
Yeah, great questions. So I think I mentioned, I answered that number one question briefly, that we need to become programming savvy, actually. So with networking, with the traditional networking, we need to add a flavor of programming, because to be relevant when the SDN takes over the plane, you need to be able to do scripting, programming, because passing the instructions to SDN controller, it's not like the normal Cisco IP interface, this, that, it's going to be like a script, like a Python script. Python is actually the major language. So I want to challenge you, if you can, please learn the programming thing, because it will have to be very flexible. There is no way you want to pass very dynamic instruction to a router or a network without having the if and else. You know what I mean? If this is this, else do this, if that. And that's programming, actually. On your second question, that's why we picked service provider SDN as the best topic, because the SDN technology is creeping in fast, but from the telecom side, not from the enterprise side. Because telecoms, we have a very large network, thousands of routers, and we are beginning to get to the point that how do we manage these solutions end to end? So I can honestly tell you that in another 12 months, a couple of network operators here will have deployed SDN. So it's fast taking stage in Nigeria too. Yeah.
Right. Thank you very much.
Yeah.
So in other words, to survive in this industry, yes, you need to learn a bit of your programming. For those who don't even like it. Okay. Although I said one question, but please make it brief. No, go ahead. Go ahead.
So my name is Stephen. I want to know, how did you come up with 2025? And can you give us some figures in terms of uptake of SDN?
Figures in terms of what?
In terms of uptake of SDN in Nigeria and maybe in Africa. Do you have figures on that?
Okay, so I just mentioned that, if you're listening to me. So I said that SDN becomes necessary when we want to manage huge number of routers, you understand? And in Nigeria, the people that has this infrastructure, this huge infrastructure, are the network operators, basically telecom operators. So if I'm to answer that question with figures, I would say that 50% of telecom operators would have deployed SDN in 12 months. If I'm to answer that with figure. But the enterprise solutions like the banks, all of these people, they don't have that kind of huge network. But remember my first slide, that most of these enterprise solutions will move into the cloud come 2025. So like the banks will see no reason to keep router infrastructure in their premises anymore. They'll rather tell some service provider, why not just give me a slice, give me a network slice, and give me this particular QoS, so that I'll have this premium treatment whenever I'm going through your network. Because why keep the routers and the switches anyway? Does that answer your question, please? Yeah, all right. Thank you very much.
Another round of applause for Tunji, please. Thank you. Okay, quickly, I'm glad to know that we're not sleeping and we're still catching up. If you think of just stand up, take a walk. The next presentation will be by Mr. James Shirua from Afrinic. He's going to be talking to us about the IP numbers registry function and services. A lot of us have refused to leave NAT alone. A lot of us have, you don't want to get your Afrinic IPs. So he's going to be telling us what Afrinic is about and then how you can go about it. All right? Here's a round of applause for him.
Okay. Hello, good afternoon. Yeah, my name is James Chirwa. So I'm with Afrinic. Throughout the day, we've seen a few interesting presentations. We've heard about SDN, SD1, NG domain, internet penetration, one thing that kept coming up was IP addresses. So anyone who doesn't know what an IP address is, I'm sure pretty much of us are in the technical field in terms of internet, right? So, Afrinic, what do we do? Okay. Seems like the clicker is not working yet. So, control. Yeah, so anyway, I'll just keep on talking. Afrinic, what do we basically do? I'm sure most of us remember Edith's presentation regarding ng.domain, right? So basically, Afrinic, we are more of another service that we are dedicated to run. We are one of the 5 regional internet registries. So what do we do? Basically, we manage IP number resources. And when we talk about IP number resources, we are talking of IPv4, IPv6, as well as autonomous system numbers. So all these services that we've heard about, SDN, SD1, domains, websites, emails, all these, there's one underlying resource that they require. That's what we call the IP resources. IP addresses, IPv4, IPv6. So scope of my presentation today, we are covering this particular things. We'll look at what we mean by the IP numbers, how these numbers are managed, and managing this, when we give you the IP number resources, what you need to do to manage them. I'll also give you a brief of the status quo regarding the current consumption of IPv4 that we have. I'm sure pretty much most of us know that all the other 4 regional registries no longer have IPv4 available. So it's only Afrinic, and I'll give you an update on that. And I'll also give you an update on services that we give on top of these IP addresses, as well as give you an update on some of other things, including policies. So like I've said, this is what we define by IP number resources. We are talking about autonomous system numbers. Okay. So yeah, anyway, here I can get it. So this is an IPv4 address. This is an IPv6 address, and we have an ASN on the other number, on the other side. So basically, that's what we do. There are guiding principles when we work. What we really want to achieve includes these particular numbers. They are unique. They have to be unique for each and every particular network operator. So we have a registration of these particular numbers. There's a particular tool that we use. You will see in the next slide for registration. We also have objective to ensure that we do aggregate these number resources as much as possible for each and every operator. Reason being, the internet has a routing table. The more we break down these numbers and push them to the internet, the bigger the routing table grows. In the end, it will require a lot of router resources. So keeping a smaller internet routing table is quite of importance, because most operators may not be able to keep up with the demands of the routers, and it may cost them more. So like I said, internet number resources, how do we manage these number resources? We use what is called a Whois database. So Whois database is a tool whereby you have to, any operator or anybody can access just to know who is using what particular IP resource. The database itself uses what we call routing policy. Yeah, it's called routing policy specification language. You can read more about it. But in that particular specification language, these are some of the objects that we use to represent this particular IP resources. So understanding these particular terms for these particular objects makes it simple for you to work with this particular host database. On top of the number resources, these three that I've mentioned of, we also maintain what we call domains. So I'll bring you back to the earlier presentation regarding ngNOG. We're also talking about domains, right? So a domain at the back of it would definitely be represented by an IP address. So once you know a domain, you would be able to know a particular, let's say maybe a website. You would be able to know a particular IP address behind that particular website. So let's give an example. You have an IP address that maybe you've noted somewhere and is providing a certain service. In this particular case, you will use this particular domain for us to be able to do the reverse and be able to know the particular website that is using that IP address you have. So this domain we deal with is called reverse DNS dedication. Another thing is routes. These are one important factor. I'll talk more about it when I reach the slides regarding hijacks. Prefix hijacking is something that is becoming more popular nowadays. So I'll touch on that, but there are more sessions coming regarding that as from Wednesday. So I'll just briefly now talk about what, I know most of you here could be our members. You already have the IP resources, but mostly what we realize is most people don't know what to do once you get the particular resources. So I'll talk about this and I'll talk about how you can do it. So this is just small steps that you have to follow once you get resources from Afrinic. So we advise that once you get them, you have to access our portal. You see the link to the portal, but you need to create what we call route objects. Like I said, these will help you stay safe on the internet. They will guard you against hijacks that we're talking about. Similarly, route objects authorization, that's another tool. It's a service that we provide. You can use that tool to also increase security of your IP traffic. So how do you do it? You access that particular site. This is only accessible by members. If you are a member of Afrinic, you have IP resources from us, you definitely have access to this. Otherwise, you may as well use this particular site. We have a web interface here. It's open. It will allow you to do certain things that either are not permitted in the first site, or you can you still be able to also. Okay. So on this particular web interface, you can do things that you're able to do from here, but also additionally some others that are not accessible here. The third one is an email. You can send an email to that particular email address. It will help you also create some of the objects that you want regarding maybe how you are using your particular IP space, or maybe how you want to define your routing policies. So these are the three tools that you can use for easy of managing your IP resources. Okay, so like I said, I've spoken about the usage, what you need to do, but why are we really spending time talking about these IP resources? Like I said, service operators needs these particular resources to run their services. I mentioned that Afrinic is the one remaining with this particular, especially for IPv4. So IPv6 is still there. If I may ask, how many here are running IPv6 on their networks? 3. So I can see very few, just about 5 hands. 5 hands out of the rest of us, which is concerning. Why? Because if you can see these figures, we are almost depleted as well. Afrinic has also almost finished its IPv4 pool. If anything, we may as well complete, not completely, but reach what we call phase 2 of soft landing phase. What does that phase 2 mean? We'll see next. But right now, by end of November, we may reach phase 2 of soft landing. Right now, we are in phase 1. Implementation of phase 1 is that an operator can come and you can get up to a /13 of IPv4. The day we reach, this is just a graph for that, but the day we reach phase 2, which I said we may reach end of November, that means everybody who wants IPv4 can only get a /22 or less than that. So I know Nigeria is big in numbers, and I know you have big operators in terms of operations and numbers as well, our customer base, that is. So let's think of it. What would a /22? That's 1,024 IPs. What would they do to you if you want to scale up your services? Will it be enough? But now that's the thing. Afrinic can't give you more than that once we reach phase 2. Implication. What are we doing? Are we thinking of IPv6? Or are we still thinking of going through some not easy to scale products that are out on in the market? That's a question for us to think about. But basically, this brings up a question. It's food for thought for most operators, especially here where we know. And at the time where we've been talking about increasing internet penetration across the country and overall across the continent. This is something that we can think of. How are we going to penetrate the markets when the basic resource we can't? So that's something to think of. IPv6, lucky enough, for those who don't have, you can as well come and see us. We have our booth. It was said by one of the presenters earlier on. If you have IPv4 with Afrinic, you can get IPv6 at no cost, at no additional cost. So we also have a session, what we call a deployathon session, as from Wednesday, whereby those who have IPv6, I'm sure you've already been communicated to, you must have applied for. You will work out a session where you start from planning all the way to be able to hopefully announce some of your part of your infrastructure also to the internet. That's part of our growth in terms of IPv6 adoption. That's something we are doing. But we at this particular juncture, when we are approaching a time where IPv4 will be completely limited, I think it's time to think more of it. Another issue that this particular exhaustion is going to cause is this particular thing, hijacking and squatting. So this is what happens. You have your prefix, somebody else decides to announce your prefix. What happens? Your services will definitely be disturbed. So this is happening already, and there are means that we are trying to resolve this. I've spoken about root objects, RPKI. Those are some of the means we are trying to control these particular issues of IP hijacking and squatting. So you need to think about it. There are always means to bypass all these issues I've raised here. hijacks and squatting, and as well as IPv4 exhaustion. So moving on to that, I'll just now talk more about these tools I've spoken about regarding preventing your traffic. These are some of the services that we provide on top of the IP resources that we give you. So when we give you the resources, there are things that you can do beyond just deploying or implementing the IPs on your networks. First of all, we'll look at internet routing registry. So this is where you store your routing policy information. It's a distributed system as well. For us, it runs together with our WHOIS service, so it makes it simple. I spoke about RPSL, still uses the same language. Bottom line, it is important and we are encouraging users. For those who would like to get more information, see me at the booth anytime. Just a simple adoption, you'd see that, like I say, hijacks are getting more and more. You can see just how the uptake is also becoming. Unfortunately, West African side, it hasn't been the same. If you can see the contrast in the two graphs, you see how continent-wide is growing and how on our western side is not. So, which means we are basically, most of us, learning and secure prefixes over the internet. We need to think of the solution. So another one is RPKI. Yeah, I'm running out of time, but we can also talk about this for those who are interested. Meet me at the booth. I can take you. We can even go to as far as signing your route object authorizations. So for those who want to implement this, we can have a chat. I encourage you to take some time. Just an adoption, you see similarly, there is a trend here that shows an uptake compared to the previous time. So these are all signs that something is changing across the world. People are adopting new technologies just to make sure that they survive well on the internet. So don't be left behind, be part of it. Reverse DNS and DNSSEC. I'm seeing there's a presentation regarding DNSSEC, so I'll not talk much on that. The other one is coming later. So anyway, another thing that we do is also we provide, now we allow IP transfers between different operators. This may come in handy when we reach the phase 2, whereby you can no longer get anything more than a /22. You may be able to get somebody within the region who can transfer it to you as long as they don't have any particular need of it. So that's a possibility. You can think of that. But we also admit for operators who have acquired each other or they've gone through a merger and acquisition, that's another way you can transfer IP resources. So just a brief update. There are a few things that we've introduced based on what we faced over the period. So we realized that some organizations were having issues making payments to Afrinic, using credit cards because maybe one of the person or they wanted somebody else to pay for them from somewhere. So we've introduced credit card payment that does not require you to log in into the members portal. You can just go on our login page, you'll find the link, you'll be able to pay. Another thing is, I don't know whether Nigeria has withholding tax regime, but if your central bank does, you can declare in advance. Just go log in into the portal, declare the amount that is charged. In that way, the invoice that will be generated will take care of everything. That will help you in ahead of time, just because if you don't do it, you may end up paying, but if they deduct that, it still leaves your account in debt. So it doesn't look good, because the day you want a service, at times you may not be allowed to access any service. So that's a thing that you can take care of in advance before it's too late. We are also introducing the IRR integration. This particular service lands outside the members portal. but we are working on implementing it within the portal so that members only log into the portal and work with it from there. PPKI enrollment interface, PPKI comes together with RPKI. So this one currently is kind of a hectic task to do, but we are introducing an interface whereby it will be, you just have to provide 3 types of information, click, and your certificate will be generated. So that's another thing that's coming up shortly. Last, I'll just quickly talk, just introduce on the policies. Like I said, we are a regional internet registry. So basically, we work on we have a governance structure. So part of the governance structure stipulates that policies are created to govern just how we manage these particular IP resources. So who actually develops these particular policies is what we call the community. Anyone from here makes part of the community. As long as you're an internet user, you form part of that community. But what we've seen is there is little participation. However, these particular policies impact everybody. So what we encourage is participate, be part of the discussion, make the decisions that will work for you. In the future, you will not have to complain when a particular policy doesn't really fit what you want. So otherwise, that's what I can encourage you. Please, and you see some of just the links you can access. If you want to, you can subscribe to that list.afrinic.net to get yourself engaged within those policy discussions. You can also contact us at Afrinic, hostmaster at Afrinic or IR regarding anything on IR. That's all that I have for you, and thank you.
Thank you very much, Mr. James. I don't know if you have any question for Afrinic, but I think you need to take advantage of the fact that they are around. For those of you who don't have Afrinic IPs, so get to their stand and see how you can get through the process of the registration and what it takes. Any question, 1 or 2 questions for him? All right, thank you very much.
All right, thank you.
All right, okay. Please, another round of applause for him. Okay, we're almost there. Thank you for your patience. I hope you're picking 1 or 2 things from the presentations. I didn't hear anything. Are you? All right. Okay, so next presentation is going to be more of a panel discussion, and then we're going to be having a discussion on the state of IPv6 in Africa. Now, Tamon Mukon is going to be anchoring this. So it's going to be a session where you can have 1 or 2 questions to ask. If people are already doing V6, what stops you? So this discussion is going to center on what are the processes? What do you need to do? Why are the other providers not carrying IPv6 for you? Are there some that are already doing that? So this discussion will help you. So Tamon, if you're around, please, can you join us? So Tamon will tell us about the state of IPv6 in Africa, and then we'll have 2 people join him. So a round of applause for Tamon, please. Once you see Tamon, you see IPv6. Huh?
Thank you very much, Cletus. He forgot a word in the title, the pathetic state of IPv6 Nigeria. So, what the other, you guys come up so we can do this together, right? I don't want to be the only one delivering the bad news.
Okay.
Yeah. So for a bit of context, right, what is it that we're talking about? We all know that The internet is powered by IP addresses, V4, up till now for everyone. There are only 3.7 billion of them, right? And just in case you did not know, if you've been living under a rock for the last 5 years, it's practically finished. James just told you that the last remaining pool of free space in the world was at Afrinic, and we've gotten to the bottom. It means that if you wanted to start an ISP in any country on this continent, you don't have IPv4 space. So if you're not thinking about IPv6, you already lost the game before you started. Now, if IPv4 is the only game in town, here is the global distribution of IPv4 addresses per capita in the world, right? If you take the total number of IP addresses given to a continent divided by its population, you get average about 5 IP addresses per person in North America. And in Africa, you have 10 people having to share an IP address. We are not on the same internet. And anyone who doesn't understand why that's a problem is someone who's never faced the challenge where you come to an office, the internet is really, really slow. And then when you call the tech guy, they say, reboot it. They reboot the router, everything is really, really fast, and then 5 minutes later, it becomes really slow. That's because in the last 15 years, if you're in Africa, the game changed. 15 years ago, the problem was bandwidth because NAT was sufficient. Now, bandwidth is no longer the problem. Ports to do NAT translations have become a problem. So we're seeing the need for what? More addresses. In Nigeria, what does that number stand at? 200 Nigerians have to share one IP address. So if you think 10 per half, 10 was bad, 200 Nigerians. So it is never, ever going to change because we are not going to manufacture more IPv4 address space. Yeah, I know some of you might have heard about IP version 10 and all of those contorted means to want to extend IPv4. Not going to happen. So here's a problem. We've got, on one hand, the internet keeps growing, existing every single person who wants to get on, right? There's Netflix all over the place. Every single television set we buy these days has an Ethernet port and a Wi-Fi port. Those things need addresses. And if IPv4 is the only game in town, we have what? Joker meets Batman, right? Unstoppable force meets an immovable object. So something has got to give. So there are 3 choices that we can do. First choice is we can buy more address space. I'll be happy if you tell me where we buy them from. We can keep sharing addresses, which we are already doing, or we can deploy IPv6. Here's my opinion. So let me start by asking my panelists, given these 3 choices, which one makes sense for your network and why? Let me start with Wale.
Okay, my name is Wale. I'm from the academia. I'm from the University of Technology, Akure. We actually have a V6 block, and I was at the August edition of the Deployathon class by Afrinic. But before I came for the V6 class, we already had a lab at my place. So where we prototyped what we want to do, how our address plan is, and how moving forward on V6 is going to be like. And a few weeks after that, we deployed V6 on the network. We have a V4 block already, which we are running full scale. But deploying V6 was a problem for us when it comes to the telcos in Nigeria. We approached, I don't know why the telcos are not here actually. We approached MTN that we are ready to do V6 deployment. We got no answer. We approached Airtel. We got no answer. But later on, we found out that they said the customers are not actually asking for V6 deployment. So the only alternative that we were left with was to go through Hurricane Electric. So we went through Hurricane Electric, submitted a letter of authorization, and within few hours, we got our V6 up and running with the help of few guys from the community who assisted us. And running V6 for us has been very wonderful. Learning from what we've been taught by the Afrinic deployathon, and doing things with the IPAM so that by the time you have your V6 broken out, we have a /48, and we were advised to always stay by the nibble. And we did that, and it's been a very wonderful experience for us. So we have a V6, we've deployed it, and it's running. Though we still have few difficulties on the network, but we hope to actually overcome.
Thank you.
Yeah, my name is Emmanuel ngNOG from the University of Benin. We have IPv4, but we see that the IPv4 we have and changing it to our private IP address is not sufficient, so we can't go around. So it's only some selected places we're using the public V4. And when it comes to V6, by the time we applied for V6, we are not of good standing. So we asked to go and settle up our build first before we could apply for V6. But being that it's only very few persons in my team who are familiar with IPv6, because I've been teaching IPv6 in the Cisco Academy, using it to configure routers, teach students. So it wasn't much of a problem for me. But the other member of the team, how can we deploy and support something we don't understand? And secondly, if we deploy IPv6, that means everybody will be visible to the internet because they, on their own thinking that NAT is a form of security. I try to convince them NAT is not a form of security. You have NAT, you still have your malware, you still have your viruses coming to the network. So it's not a form of security. So it's to encourage the users to go and get virus. So we've come across that stage now. We've made requests for IPv6. We're hoping that maybe before the end of this conference, we'll get the requests approved and we'll start the deployment of IPv6 network.
Thank you.
Okay, my name is Awal Hassan Chacha from also the Academia, Bayero University, Kano, from the northern part of Nigeria. We have both IPv4 and IPv6. We've had it from last year. Actually, I started this battle for over 5 years to acquire global resources for the university. But then anytime I get to the point of payment, I meet a stumbling block. No matter how much I try to explain to management the importance of getting global IP, they just wouldn't understand until it got to a point where we needed to deploy some services in the university and we needed global IPs and we didn't have any. And they asked me, why didn't you deploy these services? I said, the same global IP I've been battling with you guys to provide for us for over 5 years is the stumbling block now. I said, how much is this thing costing? I said, look at all the invoices I gave you, all this while. He said, let's just pay immediately. I said, no, you can't pay immediately because the ticket has been closed. We have to start a new ticket all through. Now, because of they have now realized the importance of us having global resources. Immediately, they were the ones that were on my neck to get us global resources like yesterday. We were able to get it. And luckily, we got both IPv4 and IPv6. We recently deployed IPv4, and the entire university is running on the IPv4 block. However, we've not done the IPv6. One, because the subscriber that we are subscribed to, that's our internet service provider, claims that they do not support IPv6, which is sad, really. And we we are left with the agony of having to do 6 to 4 tunneling. And of course, I'm not too comfortable with that. Not that based on security matters, but I look at it as me having to now go through the provider outside to reach out to resources that probably are going to be inside, like going round, just like we are trying to avoid by the implementation of IXPs. In any case, if that's the only option that we have, we'll go by it. But then I need to have my staff get educated on IPv6 before we delve into it. But that's where we are in IPv6 deployment. Thank you.
Thank you. So obviously, everyone is sharing addresses, doing that because for most network engineers, they learned networking and NAT was a part of networking. And so it's just stuck in their minds that the way we build networks is to use private IPv4 addresses and then do NAT. And so there are cases where entire organizations have blocks of V4 space they're not using because what? NAT. Well, if you're in Africa, you don't need to buy IP addresses. But if you wanted to, I want you to imagine there are accountants and CFOs who still have problems because I want to see the thing I'm buying. And you're sending him an email from some company in some island. I'm supposed to pay $2,500 for this. You're going to have a lot more problems. Therefore, deploying IPv6 should be your only option. So, bad, Facebook-like on deploy IPv6, right? Now, in case you're wondering, this isn't new. This is 20 years old in the making. 30% of traffic as seen by Google today is over IPv6. So as we speak, there are nothing less than 500 million people all over the world that use IPv6 only. So it's not new, okay? Now that's the map. I don't know about you guys, but Africa, we are supposed to be the black continent. I don't understand this red. Black, yeah, this red, I don't understand, right? That shows global IPv6 from the perspective of users. And as you can see, Africa is doing really, really bad. And we'd like to change that. So what is the status in Nigeria? Let's see. Only 35.7% of the transit providers into Nigeria can provide IPv6. Pathetic, right? What's happening? Of all the IPv6 prefixes that have been gotten, only 17% of them have been announced. Mind you, getting an IPv6 prefix in this region is free of charge. People have gotten it, and they're not announcing it. So, why so? First of all, you have providers who do not have IPv6. And that's sad to say because I can attest to what they're saying. My team and I, we've been working with more than, say, 20 plus operators in this country. And the biggest block is operator X, we don't have IPv6. And when you send them an email, oh, we have plans for it next year, which contradicts something that Mr. Warranty just said. On every conference, on all continents of this world, you have someone from marketing say, oh, the reason we're not doing IPv6 is because no customer is asking for it. That's just not true. Because in this country, they approve. We've sent a list of at least 15 customers, paying customers, who say, we want IPv6. And what was the answer? Planning for it next year. So that's not true. So content, 58.6% ready. Don't get excited. This is not Nigerian content. This is Cloudflare, Google, Facebook hosted in Nigeria. Don't get excited. And that's why I say it is pathetic, because there's 0%, and on a scale of 1 to 100, Nigeria does the pathetic 9.5% deployment. That needs to change. So, when I say Nigeria, I know the carry last, right? You all know that guy. So if you could, that's sarcasm, right? Nigeria did carry last in this case. So how do we fix this? So after training more than 10,000 engineers from every single country on this continent, we sent out this survey. What is your #1 deployment challenge? And as you see, almost everything that they said was also reflected here. #1, competence. I don't have the skill, I don't have the confidence to do it by myself. #2 is management. Management goes from every single thing, it's not a priority, I don't have equipment to train people, I don't have the budget to train people, everything that has to do with management. And lots of other small things. So I'm going to ask my panelists, for you guys, what was the biggest challenge for you starting your IPv6 project?
From my own point of view, was actually competence. But later on, when I found the Deployathon class, I was like, this is an opportunity for me to learn. I didn't bother consulting the management because I know what I want. So I went out for it, came for the Deployathon class. I think I actually attended 2, one by your session and by Stephen's session. And that was it. And after that, we found a way around it and we deployed.
For me, the greatest challenge is management because one, for you to travel for training, management has to approve. They have to also make funds available for you to travel. And second, when it comes to having AX number, because you need an AX number before you could announce your IPv6 and you must pay for it. So, and they have to be approved by management. So I would say more than 37% of my case was on management.
For me, the greatest challenge I will confess is actually competence. Competence, not on my own part, but on the part of people I work with. I can't stand alone deploying everything. My team has to be part of it as well. And they are still having some sort of issues accommodating or being comfortable with global IPv4 itself. You understand? They are used to nothing.
I know.
So,
I know.
So that's.
Thank you very much for that perspective. And this is the challenge we face. We all think that learning and deploying are two sides of the same coin, right? That's what we think. But that's the reality. That's unfair competition, right? You know how this story ends. This is not in the Bible. You know how this story ends 100% of the time, right? And that is why we realized at Affinity that it's just not training. Training on its own isn't going to cut it. Because the biggest myth that people have is that if I just had information, I'd change. We all know that we are overweight. Do we stop eating sugar? No. We need to do something differently. And so what's that thing that we do? So for a long time, I'd get emails like this after I do a training. Maybe sometimes 6 months later, sometimes a year later. Someone would tell me, hey, come on, I'm at the end of my IPv6 proof of concept. It was difficult, but I'm finally getting it done. And so we thought, how do we scale this? Well, we can have a process in place to get people from learning to actually deploying faster. And so that's why we came up with the idea of a deployathon and an IPv6 help desk. So the idea is go from curiosity to deployment. Of course, you can never escape the fact that you need to train people. So the very first thing we do is that we provide training. It used to be face-to-face training for a long time, but we are toning down on that. Because, again, training, especially if you don't give people, don't throw people off the cliff. It's just going to, you're going to come for the next training, and then the next one, and then the next one, and then I get irritated. So, first thing we do training, live, through webinars and online. So that's going to solve the challenge of I don't have money to send people for training. At Afinic, we're going to provide the best training for you free of charge. Now, that solves one part of the competence problem, that of knowledge. But the second part, confidence, still is there. And that's where the second thing comes in. The deployment help desk. If you want to deploy IPv6 and you don't know how to start, there's a form on our website you fill, and someone will hold you step by step with your network as an example. Do this, do that, do that. We do that remotely through an online session. After doing that for about 1 year, we realized that there's still something magical about meeting face-to-face. And then we came up with the idea of a deployathon. What's a deployathon? It's a hackathon for deployment, right? And so through this, we are able to have people come in with no IPv6 prefix, and the third day, leave with IPv6 actually running in their networks. I mean, some of you, the last deployathon were there. And so the next 3 days, you're going to be having something like this, a deployathon, where the objective is, this is not training. We set the boundary high. If you want training, sorry, that's a $5 problem. We're not solving $5 problems. When you have a $5 million problem, then we talk at that level, okay? So that's what a help desk session looks like. So on the other side, there's an entire team on in another country, and then this is Stephen and this is Bashir, they're in the crowd, and they're helping them step by step. What do I need to do? Which routers do I need to touch? Which protocols? Who should I call? Because sometimes we realize it's just that first email. And so what we found is that when we go out and do deployments, people tell us, they just like the fact that someone was able to tell me step A, B, C, D, and then they could figure out the rest by themselves. So that's what a deployment looks like, face-to-face. And that's the kind of result that you can get if you come to a deployment. You can come in with no IPv6 prefix, and by the third day, you have live traffic from your network. So I think one of the best performing operators in Nigeria with respect to IPv6 is Glo. They're the only ones that I'm aware that can connect to IPv6. Half of their customers came through to IPv6 through a deployment, something like this. And so you see, it is not that difficult. They will tell you, he will tell you, it's not that difficult if you have someone to guide you, so you're not second guessing yourself. So, you all know that guy, right? You haven't met his Nigerian evil twin, right? He says, you can dread it, you can run from it, but the IPv4 apocalypse arrives. Or should I say, here they are. So, final words from my panelists. So, what advice would you give to someone who is still dragging their feet?
I would just say V6 is nothing difficult as long as you can just pick it up and do it. If you only read about it and you don't do it, then you will never make it happen. So as long as you have the prefix, don't keep it in the file. Put it on your routers and your switches and let the thing work on the network. We are routing it on our network and we're fine. So I don't see what's stopping each and every one of us from routing it on our network.
Yeah, well, for me, I think the first stage is being here is the first stage. We should just make use of the opportunity, make the request, and if possible, get management or put the approval necessary so that at least we can all get all the steps to start. We could just create maybe one segment of our network, try it out there, let's see how it works. If it's fine, then we can just replicate that to other segments of the network.
For me, first of all, I would like to call on the chief executive officers among us here. There's a very beautiful opportunity knocking on the door right now. Tomorrow, we're going to have the last leg of this conference, and our workshop starts. And one of the tracks is actually dealing with IPs, and with speciality in IP version 6. This is an opportunity for those of us that want to learn and get a grasp of what IPv6 can do for them. That is one. Secondly, we shouldn't be scared of going into the unknown, because that's what people think IPv6 is. IPv6 is regarded as an unknown. But if you are scared of going into the unknown, you can never prosper. It's just the trick behind it. So IPv6 has come to stay. It's either you follow the bandwagon or you perish. Thank you very much.
Thank you very much. I like your last part about, don't be afraid of going into the unknown, because if you've grown your entire life running a network on IPv4 and NAT, you are like the golden fish that was raised in the bowl, right? It thinks that the world is a swirl of water every 5 minutes, until one day it meets a fish from the ocean. And that fish from the ocean will tell you of a world where you can swim for miles and miles and miles and not have to turn. What do you think the fish in the bowl is going to say? You're lying. You're lying, right? Because it cannot possibly conceive of a world of so much abundance. Don't be the fish in the bowl. Questions? So questions, we'll take the questions and we can answer them. Okay, question from Kami.
Thank you. Question, really. I'm taking something from this presentation, which is a bit surprising to me. The fact that it is possible that we have providers in Nigeria that cannot provide IPv6 support.
Shocking.
So I'm hoping that that information can live here and get to some regulator that will insist that all providers must support IPv6. Otherwise, there's no way we can incentivize the users to use IPv6. Because if you try and you hit your head on the wall of a provider, simply because of that, you will not be encouraged to go ahead. And that brings me to my next question. Is the person from Airtel still around? Now, it's a question, and I'm not sure if I'm correct. My understanding of LTE, LTE Plus, is that it actually requires the end connection to have real IP addresses, in the sense that we're no longer doing circuit switching. That's what makes it efficient. So if that is the case, it is not possible to do LTE effectively in Nigeria, except you are truly running IPv6. I may be wrong. So I'm just trying to tie those ends together that, I mean, why do we have service providers that cannot run IPv6? Thank you.
Question in the back there.
Okay, sir. Yeah, you may be right by saying that LTE, LTE doesn't actually take out circuit switch completely. There's a fallback, Like today, most of us that deployed LTE, we are not yet doing the voice over LTE. So we are doing a CS fallback. So we still use the CS network, which is still relevant. But when we get to the voice over LTE, yes, you will be right to say that we have all the devices need to have IP addresses, but not necessarily IPv6. We can still have IPv4, and still being natted, to public IPs outside. The whole essence of IPv6 is if you want to have unique IPs for your end users, maybe for machine-to-machine connections or the like. You just want that uniqueness. And when you start allocating the existing IPv4 addresses, the public ones, to end users, you run out of it in a very short time. Even if you have a /12 or a /10 with the millions of users on the mobile network, you run out of it in a very short time. And that's what brought IPv6 into play. Because when we are going into Internet of Things and all the likes now, we need to have them IP addresses. But as it stands right now, we're still making do with private IPs, nothing to public IPs, and LTE still works.
So the question is, when are you going to sit up?
No, you see, I've been listening to you actually.
the change, I was speaking to Mr. Oronti before this panel, you know, change in a service provider network is huge. And we can only start having IPv6 creeping from our business side. That's the enterprise side. So when we have an enterprise customer, say my network is IPv6, I need you to give me an IPv6 connection, you know, yes, definitely. This will make us, you know, go get the IPv6 and give it. But I was telling him that this thing, we're not getting the demand. I don't know where I was, when I was engaging him, he said he spoke to someone, but I wasn't aware of this because we had this discussion last year in Hertel on, do we need to go for IPv6 right now? Because now we still have like 800,000 IPv4s, which we have not used, public. You understand? So what would be the business justification for going for IPv6? Yes, it's good, you know, but if we are not having the demand poking us in the face, you know, why are we going to go for it? But don't get me wrong, it is good. So I was telling him that if we were to take it to the mobile space, where we have our mobile phones, I've spoken about the enterprise, right? We bring it to the mobile space. We will need to make a lot of changes, and we have two options. Either we do the 6 in 4 tunnel, that means we tunnel the IPv6 into IPv4, existing IPv4 in our backbone. You know, we take the IPv6 for access network, and then when we are bringing it into the backbone, we turn it into an IPv4 because of the huge change. I was telling you during my presentation that we have thousands of routers, like 5,000 routers. Do you understand? Making the change or making, you know, introducing IPv6 into each one of them is a very huge change. Or we go the dual stack method. We leave the IPv4 network and construct a new IPv6. You understand? So, but still, we are not seeing that demand.
And happily, as we're talking about orchestration and SDN controllers being able to, you know, make all that work easier, right? All of your IPv6 transition mechanisms can be deployed on an SDN controller and then pushed out all over the place. So here's a message for your management. There's this thing called vision, right? You don't always have to wait for the customer. Sometimes you have to solve $5 million problems without the customer prompting you to. That's business decision.
Okay. Yep. Yes, thank you. Sorry, Shagun has taken some of my wind out, but wanted to share 1, 2, or maybe 3 things. Number 1, yesterday morning, we have a connectivity sponsor here, and somehow I had sent a request saying I'd like to have 500 V4 IP addresses for this event, because thinking, okay, 250 people, 2 devices each, it should be fine and not need to NAT. Unfortunately, that request got lost along the line, and yesterday morning, someone says to me, oh, here's your /30 and your /29. And I'm like, /29? No, you didn't get my request. I want a /22, or if it's really bad, give me a /23. So yesterday morning, so it's an unusual request. What are you guys trying to do in that place that you need /23? I'm like, 250 people times 2 devices.
Fish in the bowl.
That's
fish in the bowl.
Already gone. So we go through all of that, all through yesterday, up till 3 a.m. this morning. And to everybody, they say, what kind of device are you using there? I'm using a MikroTik. They said, yeah, the MikroTik has an ability to NAT as many devices as you want. In fact, you only need the /30. I'm like, so you were spot on there where you said 0.02 IP addresses, that's 1 IP address per 200 Nigerians. We're probably doing 200 of us behind 1 IP address here as it is today. So the problem is that the average Nigerian customer does not ask for IP addresses like that because they don't think there's any performance problem. And so the second thing I want to go to is we've had several conversations about IPv6. And you say people are not doing IPv6. And I'm like, people are not doing IP nothing. Because they're not asking for public IP addresses. They want to plug that thing in, the browsers, And that's because we're not using machine-to-machine stuff. We're not hosting content as much as we should be. So for the average Nigerian, you're just a consumer. You're fetching stuff and you don't think there's any reason for you to use IP addresses. So I think that when we face the issue of our content, our hosting, our services, our creativity and innovation, then we'll get to the point where every time somebody says, I want an IP address from Mr. whatever operator it is, he finds out that he's out of the IP addresses that he has, and he starts to market to them. And you know, you could do IPv6, and you could have lots and lots of IP addresses. So I think we will push. It's always the money. Business will push. I forget what the third one was. There's one more presentation or two, so I'll just let us go on to that.
I'm also surprised because on your network right now, there's no V6. So did you also request for V6, and what was their reaction?
So on this network here today, well, I gave it as an option. When I got the resistance to giving me a large block, I said, okay, you know what? Give me a handful of IPv4, give me a load of V6, we'll take care of it. I think there wasn't enough time for them to do that because I know that main one has IPv6 on their network. I thought you were asking about my home network.
Okay.
I tunneled through Hurricane Electric, sadly.
Please, I'll take two more questions. We'll have two more presentations.
Question from Mohammed. Question from Mohammed.
Sorry, Ethel, we're bashing you because you're the only service provider that is here that bash. Now, one of the reasons why you have, you say you have how many? 2,000 IPv4?
200,000.
Now, you will have 200 IPv4, 200,000 IPv4 because I have one of your customers who has an STM1. It was a big challenge for the customer to even get a /29. To even get a /29 as in, they just simply gave, I mean, can you imagine giving somebody who has an STM1 with you a /30? And then he now said, see, I need this, I need that, okay, right justification. Does a customer with an STM1 need justification for a /29? It does not need. So that's the reason why. And when you say business case, it's not just business case you need to look at. Now the government and NCC is coming up with issue of cybercrime, security, and so on. With IPv6, it makes it easier to solve crime. It makes it easier to solve cybercrime. We're not just simply going to be talking about, okay, because we don't do machine to machine, and because of that, it doesn't make any business case. There are so many things that with IPv6 will solve a lot of problems that Nigeria is facing, specifically cybercrime. For us, the ISPs, they come today, NCC come today and say somebody is doing something on your network, and there are like 200 people on one IP address. How do you, despite the fact that you are storing the data and everything, how pinpointing who used the IP address at this point becomes a problem? So definitely, we are not just simply going to, yes, I agree with you, that yes, it's difficult for you to convince the management to bring up this and then your equipment, you need to do quite a number of things, but we should not just simply limit it to business cases alone. It's going to go a long way to solve a lot of problems that the smaller ISPs and your end user, the enterprise and so on are facing. If you need to go into, see, when you say customers are not requesting for it, I don't agree with that. Honestly, I don't agree with that. Because I'm one person, I have two SCM1 with you guys, and I'm one person that has been hammering on IPv6 for the past 2 years. I'm not the only one, there are so many. There are so many universities that are on your network that have been requesting for IPv6. So we should just simply try to not just simply look at, so that we don't get left behind, just like we were left behind with. Something can come up again now. A new technology can come up which requires something. That is when we'll now start doing fire brigade because we need to catch up with them. So if we start working towards it now. Thank you.
All right, one more, please. You see, we're running out behind. I'll come. Okay, sir.
Okay. My name is Mohammed Rodman, and I happen to be the chairman IPv6 Council of Nigeria. And together, you know, with my colleagues, we've been trying to push for IPv6 all over the place. The pathetic situation you are seeing here is that 83% of all internet users in Nigeria are mobile. And mobile users do not really care about IPv6. because 99% of all the services that they can reach on, they can reach it on IP version 4. So there is no need of them to really push for that IP version 6. So the pathetic situation you see there, because even if the smaller networks, all of them adopt IP version 6, if the big players that have the huge networks, some of them have as high as 65 million people on their network, yet they are running NATing, and they are doing carrier-grade NATing with Huawei devices that are very powerful, and the efficiency is really high. So what I just wanted to hammer was the last point. That's what I wanted to raise, the security aspect issue. Right now, it has become a challenge where the regulators, government want to really trace users, that have abused, that have perpetrated crime. Just like the way they are doing call masking, they are doing the same thing with IP addresses. So there was a time that NCC wanted to do IP login session to say, okay, in the NAT table, but the ratio of the Nigerians, translating between IP version 4 to private IP addresses is extremely high. And therefore, I think it's only government that can solve this. Because if you look at it, the Belgium case scenario where in Belgium, they restricted the ratio of the NATing that you can do. One public IP address, maybe to 50 private IP addresses. With that ratio, they will be able to track and trace people. And that compelled so many network operators in Belgium to really move to IP version 6. But in Nigeria, it's not the situation. They really don't understand maybe that concept. And as long as we don't do the big players, the top 4, forget it, of all the smaller operators are doing it, the impact that you will see globally is very minimal. That's just my comment.
All right, thanks.
Thank you.
Let me just round this up. One clarification on mobile. You said that mobile customers don't care about IPv6. Correction. Mobile customers don't care about any IP. They don't care about any IP. It is the job of the people who run the business to sell something different that might include IPv6. Biggest example, when the MP3 players came out, everyone went, I have 1 gig, I have 405 megahertz. What did Apple do? 5 million songs in your pocket. It was another way of saying 1 gig. They never used the word 1 gig, but 1 gig was what they were selling. That's the difference, and that's the challenge for business leaders, right? There's a problem. I think when it comes to business case, if you're looking for a business case for a $5 problem, then you'll be figuring out about NAT and all of those stuff. When you start looking for a business case for a $5 billion problem, you think bigger, and then bigger, and you get to IPv6. I guarantee that. Thank you very much. Let's keep this conversation alive on the mailing list.
All right, thank you very much. So the Airtel man, I don't know, you're the only provider here, so let's be fair to you. Please respect 1 minute, please.
Yes, sir.
1 minute.
So in answering your question, it doesn't matter whether you have STM1 or STM4. If you need a /22, as long as you fulfill the business case to be given to you, because we have it. Secondly, on this IP login session, yes, Mr. Mohammed was aware. We had a meeting with NCC, and we have a solution. NCC compelled every operator to put up a solution for cybersecurity. And we have a solution that gives you up to 2-year record for everybody to the nearest second that uses any IP address. So the fact that we're using carrier-grade NATing does not mean that we have no record of the people. And we've been given feedback to Interpol, to DSS. We've gotten requests from them, and we've given them feedback. So we have a solution, a regulatory solution for that. So that's not a constraint at all. So the carrier-grade NATing works, and we have the records there.
All right, thank you very much. So Afrinic are still here. They're here till the end of the week. So any question, but the good thing is that, please, there's no reason why you should still be running NAT. Make sure that you get your IPv4 and then get your IPv6. Please, another round of applause to all of us for the contribution. Okay. Now, I don't know if Mr. Aderemi Adejumo is here from Commercio. Oh, okay. Please. Yes. Okay, so we'll be taking a presentation on preparing infrastructure for the 21st century and beyond. Thank you for your time, please. We're still, after this, one more presentation and we're out of this place.
Good evening, everybody. My name is Remy Adejumo. We run a local cloud platform in Nigeria and felt it would be interesting to talk about what we do and the challenges for us in Nigeria from a cloud perspective, and also how we move forward from there. It's been interesting. I've been sitting here for a few hours now, and I've watched some of the presentations, and it's actually been quite interesting to see what's been talked about. So what I wanted to do was, you know, I think one of the things that's missing, especially from the presentation, I mean, from the discussion that we've just had about IPv4 and IPv6, is that, as Mohammed says, that, you know, a lot of things has to be driven by policy and the government. It's preparing us for the future. So we can argue about it now and talk about how things are not really necessary for now. But I think we shouldn't, like someone said, we shouldn't have a fire brigade approach that when it's really necessary is when we go. It's the same thing with the direction of the economy and the necessity as to what do we do with the challenges we have today. And what I said, I mean, you know, we said the government policies is not a valid strategy for economic growth. One of the key things or the major things that they've been doing so far, there are two major things that has been happening in the economy in Nigeria. One is the closing of the border. The second thing is the push and the pressure on banks to give out loans. But I feel that, you know, you can't do one thing and you don't have something to complement it so that you can make a success. The thing about it is that there's no stimuli for economic growth. So why do you want to ask people to get loans when there's nothing they're going to do with those loans? So for me, I think it's a recipe of disaster if they don't look at the other side and provide the platform for that to do. So if we drill down into what we're looking at in terms of from a cloud perspective and from the IT perspective, I mean, there's some facts that I've put here and talking about the challenges of the economy. There are challenges in the Nigerian economy. A lot of this is what determines the fact that you don't have that growth, because every single business is distracted by just trying to survive. I'll just move on and look at it. So, you know, if you look at everything and all that, every day data becomes more and more important. How are we going to house it? How are we going to use it? How are we going to make it effective? How are we going to utilize it to improve our lives? These are the questions that we keep asking, and we see different things that are being done. Everything from the necessary of healthcare, marketing, social media, even the IGR that the states are looking at. So if you look at it, really what my talk is about is talking about cloud adoption. And when you look at cloud adoption, what are the drivers for cloud adoption? The drivers are the fact that over the years, a lot of companies are sitting there and faced with equipment that are end of life. So when they bought this equipment, they bought it at an exchange rate of 120 naira to one. There your exchange rate is nearly 400. So you find that, and these same companies have had a decline in revenue, so they're not in a position to spend 4 times what they spent 5 years ago on the equipment. Secondly, we still have a lot of challenges in terms of power. We are generating the same power, you know, for the last 20 years or so. It's not really increased in terms of delivery, businesses and all. So the cost is going up for them. Cost of the equipment they have to use, in terms of the infrastructure they have to do to put, to have your IT infrastructure within your going up every day. So when you look at it, you've got to make decisions that it's going to save you. Moving to the cloud is one of those decisions. By moving to the cloud, what you're doing is that you're taking away that need to provide the infrastructure yourself, and you're just moving your cost from a CapEx to an OpEx. So if you look at it, I mean, lots of things written here about all the things. The moving to the cloud lowers your total cost of ownership, enables business continuity, gives you the agility. You're replacing legacy systems. You're bringing yourself into the 21st century in terms of the flexibility and the things you're able to do. So you know, cloud strategy matches the need of each applications, the things that you need to do, and the way you need to work. So, got some things in there that talks about that. So, the role of technology and infrastructure in the competitive economy. There was an interesting point made by someone, and I think as we move into, as technology develops and the options are being brought, I think one of the greatest fear is that people feel that they'll be made redundant. So you can imagine an organization with a data center, with data center staff, things like that, and they feel that by moving to the cloud, they're not able to do, they would be out of a job. I think what you've got to look at is that it's an evolution. You need to evolve. Businesses need to evolve. People need to sort of, you know, do other things, or you become more business focused rather than doing that infrastructure, because the infrastructure really is not a business-centric function within an organization. So we talk about why the cloud. Cloud solutions need little or no capital outlay by the customer because it's the OPEX, not the CAPEX. The cloud solutions cost less in terms of the TCO because save a lot of money, because you don't need to start worrying about the raised floor. It's actually quite interesting. I know a large company in Nigeria, and their data center business, they've actually done no data center business this year. So you find that there's actually a lot of people that have actually moved across. But just to talk a bit about that, there's a lot of confusion in terms of what we're talking about when we talk about the cloud. What I'm describing here is the infrastructure that businesses require to do their business. So we're talking about their servers, talking about all the infrastructure and the way they're going to use it. The challenge for them is that these costs are going up. You just need to spend so much more money to achieve the same. Also, you don't have the flexibility. The cost of even, you have challenges in that you're trying to test new systems. It doesn't make sense to buy infrastructure, test a new system, because you only want to do money for 6 weeks. That's where the cloud comes in. You can go in, use that infrastructure for a few weeks. Even if you want to do a load test, you want to do performance test, you want to do a proof of concept test, whatever the test is that you want to do, get the equipment, do the test you want, and move on from there. And you know that it will work and give you what you want. There's, if you look at it now, I mean, especially with the banks and a lot of organizations, fintech and all these sort of things are the edge for them and the areas they're looking at. Banks are now employing chief digital officers and things like that. I think they're just doing that without really knowing what are these guys going to do. They're not doing it because they have a plan. When I look at what we're doing in Nigeria with against what is being done, you know, abroad and all that, you see, take the banks as an example. They're spending absolute billions in terms of research into artificial intelligence, research into machine learning. We're not spending any money. One of the key things is that there's a requirement and there's a demand for large data repository. We have none. There's no way that you're going to find out what the trends are, what the needs are, and what you want to do for people. You don't have that data that you're going to mine locally to say this is the habits of people. Even with telcos, it's the same thing. How do you know what your customers need if you don't have the data and you're not mining your data and you're not looking at the data to use it accordingly? Also, the fact of the matter is that the when you look at artificial intelligence or machine learning, which is really the forefront of technology and one of the key areas of development, if you don't have a foundation of data or repository, there's nothing you can do. There's nothing, you can't work on anything. You can't, and these are things that you can't import. You know, our culture is to import everything. We can import the technology, we can import the know-how, but we cannot import the data because the data is the pattern of the people. The pattern of the people differs. So you can't take the pattern that's been done in America or in Europe and bring it to Nigeria and try to adopt it into the Nigerian market. You've got to grow from the ground up the way things are going to go and the trends in our market. So in any area that involves data, it's local to the culture, it's local to the habits, it's local to the trends here. So if we don't start to put the foundations in place, and we're going to fall into the same trap where we're going to be asking, like we're asking, why IPv6? We're going to be asking, why the cloud? Why a data repository? Why research into machine learning? Why homegrown technology? A lot of these things, I mean, there are a lot of ideas. I mean, it's interesting that there are a lot of people here that are from the academia. But I think if we don't have the policies from the government and we don't have an enabling environment to develop, because the brains are here, the people are here, but I think the two lacking things is it's policies and the funds in order to develop our own technology so that we can have the same thing as the trend that's going in there. I mean, one of the interesting things is to see what they're doing in Rwanda. If you look at Rwanda, I mean, yes, it's a smaller country. I think the number of people in Rwanda is probably the same as what you have in Sulere. So really, it's not, it's easier for them to maneuver in terms of that, smaller economy and all that. But they're going, you can see there are many, many areas that there's so much strides in there. And these things I'm talking about, they're putting it in place already so that they're setting themselves up so that they can meet the requirements of the future. So this is just the normal stack that you see between the IaaS, the PaaS, and the SaaS, just to describe the different components of the cloud and how things work there. Yeah. So we say, why should Nigerian businesses move to the cloud? Advantages of cloud to developers. Again, we have a lot of, I think we are one of the largest countries with one of the largest hubs that has hubs in Nigeria. Now, a lot of developers are developing, trying to put things together, but I would say that 90% of them are actually hosted outside of the country. They're not hosted locally. And the second thing about it is that they're not even using the cloud to its max. What I mean by that is that when I talk to a lot of the developers, what they do is that they put the applications per customer. They don't look at multi-tenancy, they don't look at multi-homed environment and things like that, which would make it easier for them and would also be cheaper for them and would also give them a bigger customer base because of the cost involved in their strategy in there. So again, I think on all ends, even from the people, there needs to be a lot more knowledge about what is involved in terms of cloud computing so that you know to create the right strategy and the right platform to say, this is what I'm going to do. I'm going to do it so that they can be that close. When you move along in that area, it actually reduces costs, saves costs, and it actually creates an enabling environment for more efficiency and better utilization of technology. Just talk about the threats in there. I mean, some of the things I've covered already. The lack of collaboration, that's one of the key things. That again, because we don't have the sort of we don't have the long-term funding in this environment, we don't have the grants, we don't have sort of the lack of financial support, the fact that you know, one of the initiatives we have, like with the government pushing the banks to have a higher loan to whatever. But the problem with that is that it's not really getting to the right place, and the conditions that the banks are putting down cannot be met by 90% of the market. So I mean, I don't know whether people saw it, the huge amount that the banks were fined because they didn't give out the loans simply because they didn't have the people to meet. And then the poor knowledge and not really understanding what the cloud is and really understanding how it can enhance businesses, save money, and give a better environment. So, I mean, I've talked about it in terms of the repository, the fact that a data repository is one of the key factors. Talked about the fact that the saving of costs and things like that, and then the agility and flexibility by having as opposed to having a private infrastructure. or having individual infrastructure lying around. Thank you very much.
Thank you very much, sir. So we'll take the last presentation and then we'll take the questions together. All right. Thank you. You've been very great audience. So we have Mr. Stephen talking to us about protecting your DNS data. And that's the last presentation. Thank you, Mr. Stephen. Please a round of applause for him.
Hi, everyone. Hi, all of you. I hope you are not very tired. Let's talk about DNS and particularly our DNS data. And why do we want to talk about DNS data today? We have been talking a lot about connectivity, infrastructure, the content, and all of those. And we forgot about this very interesting piece of the internet, which is the domain name system. We heard Nira talking about the .ng earlier this morning, and I want to do something in the same direction. So I am Musa Stephen Honre. I work for Afrinic as a trainer, but here I'm talking in my personal capacity. So any of those DNS services I'm going to mention, I have no affiliation to them. I just want to be a do-gooder for the internet, okay? So the domain name system is not very good for cybercrime and privacy. And what is the DNS right now? We know any single piece of device that connects to the internet uses the DNS. So the DNS is a very, very critical service for all our devices that are connecting to the internet. And because it is very critical, it becomes a very attractive target for the criminals out there. And you know that by default, the DNS data is transferred on an encrypted mode. So it's plain text. Since it is plain text, it is very easy for criminals to hijack the data, to eavesdrop, and either they will send you fake DNS resolution, or they can hijack, or they can steal your data, and this data they can use it for malintended purposes. So because it is very critical for us, we need to think of a way of enforcing the DNS and getting it more secure with technical means. Okay, so I guess all of us here, we know what is the DNS. And the DNS happens to be the phone book of the internet. We can easily remember names like www.example.com, but devices that are connecting on the internet, they don't know those names. They use either IPv4 addresses or IPv6 addresses. For us, it is very difficult to memorize 100 of those, 50, 10 of those IP addresses. So we have to rely on the phone book of the internet, which is the domain name system. And this domain name system happens to help us transparently for any device that is connecting on the internet, your computer, your smartphone, your tablet, and even your IoT devices, like your kitchens, your toilets, your fridge, your car, and any single piece of device that you think can connect to the internet needs the domain name system. So, why am I talking about the domain name system here? Because there are some problems related to this system which we need to look very closely and see how we can handle those. I wanted to talk about how the domain name worked, but we don't have time for that, so I will skip. But the slides that are going to be shared will have reference materials for that. So I will go directly to what is the exact problem. If somebody can help me fast forward to slide 18, that would be good for us. All right, thank you. So the first problem is when your device is querying a recursive resolver, it sends information, and the first information that is sent is your IP address. And this IP address happens to be a protected information. In some jurisdiction, we talk about PII. Those information, you don't want to share this information, because when you share this information, either the CCTLDs, the TLDs, your service providers, they can store this information and later sell to big organizations who will use this data for money. And you don't want that to happen. Your IP address can be shared, as well as all the softwares that are on your computer looking for updates, malintended softwares on your computer. With your DNS queries, we can know that your browsing history, your email, and all the type of information that you don't want to share on your computer. So it's very, very important to think of that. That's the first problem. So the first problem is the PII information. The second problem is about performance. When you are using the domain name system, if you have a unique server that, or a cluster of servers that are sharing the same fate, let's say you have a power failure. If you have a power failure, then you will now have to use some famous resolver out there. And many of us, we know those servers out there, like the 8.8.8.8. How many of us here are using the 8.8.8? Nobody? Okay, so if you have your computer open, can you ping to 8.8.8? Can someone ping to 8.8.8.8 and let us know the latency right now? Okay, no computer ready to ping, but I can tell you, if you ping, the latency is going to be very, very bad from here. And, but okay. Whoa. Whose service provider is that? I guess it's main one, right? Okay, just for your information, main one is having a Google node in their network. And we are going to talk about that later. But if we leave main one network and we want to do that ping again, it will be very bad, around 1,000 milliseconds. And that is very bad for our network. So let's look at the other problems we can have with the DNS. So we talked about the PII information which you don't want to share. We talked about the problem of the how we talked about robustness of our DNS servers, and if our DNS servers that we have in our network are not capable to resolve, maybe due to power failure or some system outages, we will now have to rely on some servers that are very far away from our network. And if those servers are far away from our network, performance will become, we start having performance problems. And another thing, when we are doing DNS resolutions, we can have man in the middle. Somebody sitting in the middle of our network can eavesdrop, steal our data, either send us back fake DNS resolution or direct us to wrong websites. And because we are using those systems that are unprotected, if our DNS servers are far away from us, our DNS queries can go through other jurisdictions that will use those data either to supervise our history, either to supervise what we are looking on the internet. So that said, first in the PII information, second, the performance of our DNS systems, third, our DNS queries being susceptible to be hijacked by criminals, and then Now, if we are looking at an ideal domain name system, which type of solutions do we want? Let's talk about those solutions. Before going to the solutions, I want to talk about the QNAME minimization. So the QNAME minimization is something that is very new right now. When you send a query, like you want to look for a domain name like www.example.net, the first thing that is going to happen is that query is going to be sent to the root server, which is the .NET in this case. And all what that server needs to know is the .NET. But most of our DNS systems right now will send the entire query to that server, that is the www.example.net. And because we are sending this much information to the .NET server, these people can hijack our history, and then they will later share to those big organizations out there. So the QNAME minimization is a system whereby you send to an authoritative server only the exact information they need to return you the either the IP address of the domain name that you are looking for or the next authoritative domain. So if I want to query a domain name like www.example.net, I will send it to my resolver. My resolver has to send only the .NET to the root server. The root server will now point me to what is the authoritative domain name server for the example, that is the example.net. The next server is going to send me either the IP address of example.net or the next authoritative server. So I don't want to send all that information to a single server, because when you do that, what the TLDs will do, they will lock that information and they will later on sell it. So this is all about the QNAME minimization. And the last problem which we'll have with our DNS is about the security of the DNS. So right now, this graph, I put it to show you what are the DNSSEC validations right now in Nigeria. And I can assure you we are doing very bad. Currently, we have 3.7% of the domain names sitting in Nigeria, or the domain name sitting in Nigeria doing DNSSEC. I have the link. I have a link there. You can use this link later to see how your network is doing. So is your network doing DNSSEC? I asked that question earlier to Nira, and they said the project is paused for the moment, and they are going to pick on that maybe next year. It's something you definitely need to do, because the DNS is very, very critical for the internet. So this is DNSSEC validation in Nigeria. And that is the last problem I had to share about. Now we are going to look for the ideal solution. So the first, if I'm looking for an ideal solution for my DNS system, I want a DNS system that will not share my personal identifiable information, my PII. I don't want you to share my PII information. So that's number one. We don't want that to happen. When I'm sending my request to my DNS server, be it 1.1.1.1, be it 8.8.8.8, be it OpenDNS and all of those solutions that you are using, or even the DNS server of your service provider, you don't want them to share this information. So that's the first criteria we want to see in our domain name system. Second criteria is you want your DNS system to be able to support encryption. That's the second criteria. And right now, talking about supporting DNS encryption, there are two standards from IETF. The DOH, DNS over HTTPS, which some people think is evil because it is like taking power from one source to the other source. And when you take this power from one source to the other source, right now, the only DNS over HTTPS providers in the world are residing in the US. And you don't want to be sending all your DNS information in the US. So that is bad, that is evil. And you also have DNS over TLS. So the next one is, I want to be able to filter for malwares. Right now, if I'm using my computer, I know that I can install an antivirus, and that antivirus will filter for malwares on my computer. On my mobile device, on my mobile phone, I can install an antivirus. But now I have a question for you. How will you install an antivirus on your connected fridge, on your connected toilets, on your car? Do you know how to do that? Do you know how to do that? So if you can't do that, you want to be able at the network level to filter malware. So that's the third characteristics I want my DNS system to offer to me. So the next criteria is, if we could build an ideal DNS system where everything sits in a box and every resolution is happening in a box, it will be safer for us because there will be less men in the middle. But that's something very, very difficult to build on the internet. Now let's look at the possible solutions out there. I'll talk about not-for-profit later. Let's look at the possible solution we can have. So the first solution is Cloudflare, and I talked about Cloudflare earlier. And there is something, Cloudflare is a bit good on privacy, but there is something about Cloudflare. When you are using Cloudflare, your data is stored for 24 hours. And then after that, that same data is being anonymized and sent to, who guess? To one of the IRR, I don't want to call the name here. So they will anonymize your data and send there for statistical analysis. If I have your data, I can tell you, I can easily guess who you are. If you tell me that you drove this morning to this conference in a blue BMW, I can easily locate you. Okay, so it's this thing about anonymization of data is just something that is not effective at all. So I don't want my data to be stored. I don't want my data to be shared. The next solution is Google 8.8.8.8, and we all know the history about Google, right? Everything is sniffed, even your emails, they go into it. So that's not something I would recommend. The third solution is the Quat9. Quat9 is actually, right now, according to me, I'm talking in my personal capacity, the best. Because they will give you privacy. They will not store your data. They make sure your data is not stored. They will give you security. They will filter even at malware level. And right now, if you are using an Android phone, there is a Quat9 solution for Android, which you can store, and any malintended software that is trying to go through your phone will be blocked. So right now, all the criteria I named, I talked about sharing the PII information. Quat9 will not do that. I talked about filtering at malware level. Quat9 will do that, will filter for you. And I talked about the possibility of having a solution in a box that will be able to do all the resolution for you. Right now, if you look at all the IXPs in the world, they're having a box which is deployed by PCH. And Quat9 happens to be a solution between IBM and PCH. And when PCH goes at an internet exchange point like IXPN, if you ask them right now, they have a box that is installed by PCH. And on that box, there is a Quat9 solution. That Quat9 solution, also, on that box, there is also two root servers, the D root and the E root. So it is possible for you right now, if your service provider is peering at IXPN, that all your queries, your DNS queries, get resolved at IXPN without leaving the continent, without leaving the country, without even leaving the state. All your DNS queries can be solved here. Meanwhile, for some, all of you that are using the 8.8.8, if your service provider is someone else than main one, then your queries definitely are going to go out of the continent because apart from Min 1, there is no other 8.8.8 nodes here in Nigeria. And worse, I told you that 8.8.8, they will store your information and this information will be used for commercial reasons. So Quad 9 is, for me, the best solution right now. The next solution, you have other solutions like OpenGNS, but we all know OpenGNS was bought by, OpenGNS was bought by Cisco, right? And you have other solutions. So Quad 9 is, just 1 minute to conclude. Quad 9 is the best solution right now. If you want your network to be protected, if you want your information, your privacy information not to be shared, if you want your DNS queries to be very, very fast because your upstream provider must be peering at the internet exchange point, and most of the domain names like the Amazon, Google.com, they reside on your IXP network, and the resolution will be faster than going all over to, I would say, Oyibo country to get resolved before getting back. Then the better solution for you is Quad 9. And more to that, Quad 9 has like a contract with big security organism out there. They have like a list of websites that are blacklisted, and in the Quad 9 application, you get filtered at the network layer. So I'll stop there because that was, my time is up.
All right, thank you.
If there's any question, maybe.
Thank you very much, Stephen. Please, a round of applause for him. At least if I've not picked anything from here, I have picked the Quad 9, is it not? Because I know that with Quad 9, I am secured. So my first question to Stephen is that, is there a possibility that Quad 9 will also be compromised tomorrow?
Compromised as in
the sense that, the same way that...
Okay, very interesting. Yeah, very interesting question. I talked about OpenGNS. OpenGNS was open and free. We all know that. But at the point they got bought. Quad 9 has this advantage. It's a non-for-profit organization in the US. And the jurisdiction of US bounds people from like buying non-for-profit organizations. So it is very, very impossible in the nearest future for Quad 9 to get compromised or bought by any other organization.
Thank you very much. Okay, thank you, Stephen. Another round of applause. So we'll take, I don't know if you have any question, 2 presentations we're taking. One from Mr. Aderemi Adejumo, where he spoke about preparing infrastructure for the 21st century and beyond, and then the one by Steve. We'll take 1 question each. Any questions for them? Yes. Another person? Brief question.
Sorry, I wanted to avoid asking too many questions. 21st century infrastructure, sir, where are you? Mr. Adejumo. Okay. When I saw your topic, sir, I have 2 quick questions for you. When I saw your topic, I was hoping you were going to spend some time talking about special infrastructure for the 21st century. But you spoke exclusively only about cloud services. So I'm hoping that you'll be able to say one thing to us about something special about, we're in the 21st century already, right? Okay, so tell us something, I want to hear that. Secondly, you are a player in the cloud services arena, sir, right? So I'm quite impressed to see, you said you're a slightly small organization. So I want to be inspired by how you are surviving in the cloud services space as a small provider. 2 quick questions. Tell us something special about 21st century infrastructure and how are you surviving as a small player in the space?
An interesting question. But you know, it's always very difficult in a short space of time. And I didn't want to spend too long in that. So I really jumped through what I was saying. But to answer the first one, you see, the point is that technology today is moving away from individualism into a collective arena. So you don't have that thing of saying,
I lost my words.
Sorry, the mic is still on over there. You know, you don't have a situation where each person is building each thing. So when I talk about a cloud, there's so many things. Are you familiar with something they call the Operation Jedi? Okay. For everybody else, this is the Pentagon. They've been trying to, it's been going on for about 2 years. They've been looking for a cloud platform, for someone to build a cloud platform for the Pentagon. So basically for the American defense, they're the largest spenders of money. No, I mean, in terms of what they spend on defense, they're the largest in the world. Now, this project is going to cost 10 billion. If you look at it, cloud computing at the moment, I think next year they said it's going to exceed 200 billion. So you can see that this project is 5% of the world spending on the cloud. So if you have a major player doing that, it tells you the direction that it's going. Because these guys aren't messing around. They're not just bit players. They're a major player to say, look, the direction is get a third party, an expert who knows what they're doing, build a platform for us. And that's what they're doing. So really, the detail and the specialization is not in the platform, it's in what you're putting on it and how you're using it. And what you're doing is that you're making, you're setting up something to say, if we sit here, anybody from anywhere can connect to us and there's a lot we can do. And I'll tell you this much, it's far more secure than being in your own premises. I mean, I can talk even on just on security on its own. So security is a key thing that you get out of that sort of thing. So that's the issue that we have there. So move on to survival. How are we surviving? I would say we're doing okay, but we could do much, much better. We don't have the laws to protect us. So what you find is that our potential customers would rather sit outside of Nigeria because you know that sort of thing. Let's buy something abroad rather than buy something local. I just wrote an article which will be published, and you'll see that talking just about this. And the fact is, we have data centers because there are two components to cloud: a data center and a cloud platform. Our data centers, Rack Center, all these guys, they're internationally certified. So they're as good as any other data center anywhere else in the world. For us, as our platform, we won Huawei's Cloud Partner of the Year last year. We're about to become VMware verified, which means that we've built a platform as good as any other platform anywhere in the world. And thirdly, we're also PCI DSS certified as well. So we're as secure as anything else you find in the world and all that. So all that is there. But it's just that, you know, adoption where we're sort of reticent about it. But we have some major customers on us. We have international customers on us as well who have decided that they want to do business in Nigeria and they've decided to be on a local cloud platform to do that. I hope that answers your question.
All right, so thank you. I mean, you guys have been great. I'll get Rashida now to give us the vote of thanks and tell us about tomorrow. But we need to thank all of you, especially Mr. Mohammed, the president of NIRA, who has been with us all through the day. Please, a big round of applause to him. And all of us, I cannot mention the names, but all of you were grateful for having you. So Rashida, give us the vote of thanks and tell us the plan for tomorrow. Don't forget about our gaming device. If nobody wins it, I'll take it home.
Good evening, all. So on behalf of the ngNOG Organizing Committee, I would like to thank you very much for your time here. You basically spent the whole day here. I would also like to tell you about tomorrow's events, the Day 2 conference. It's going to be panel sessions, keynote address, and the panel sessions are not going to be as technical as they were today. And of course, more networking for tomorrow. We also have a technical hands-on workshop, which will start from Wednesday to Friday. And it also includes the pairing and interconnection forum and then the AfriNIC IPv6 deployathon. And then most importantly, I would like to thank our sponsors, without whom this event would not have happened. Facebook, Google, Netflix, Flex Optics, Internet Society, WIOC, Layer 3, MDXI Main 1, Rack Center, Medallion, Afrinic, IXPN, NIRA, MIDS Network, NISTEC. ngNOG has a lot of friends. Well, most importantly, so we look forward to seeing you tomorrow. There's going to be a raffle draw for someone to win the Oculus, as mentioned by Cletus. Once again, thank you and good evening. Okay, sorry, please, for those of you going back to Surulere, there's a bus outside that will take you there.